to you. So without further delay, I'd like to give you the floor to start this workshop.
You can visit my website to see some of my research publication and my research areas. Most of my student research topics are actually put on the website. You also have a lot of research materials available for you to use if you want to use in your classes. So you can visit as you go along. So one of the things I would like to start with is every time I do workshop, there are many people who don't actually listen to what the instructor is telling. This is a common problem everywhere I've seen. In many countries also it's the same. Some of the things I'll be discussing, they are not actually from textbooks. They're actually from the many years of experience I have supervising PhD and master student, and also some of the workshop I've attended all over the world. So I will also introduce to you some of the researchers I met along my 31-year career. People who some of you cite in your papers, they will be also briefly shown to you so that you can see where some of my discussions are coming from. So this is the problem we are facing with many institutions in the world now. For ranking purposes, somehow publication matters because it is about reputation. So the more papers you publish in top level journals, what they meant by top level journals is those which are indexed in SSCI and SCI. Now most of the ranking uses publication from journals which are ranked in Scopus. So at least a Scopus level or higher, that will give you more visibility. Okay, the more visibility you get, the higher will be the ranking in all this ranking body status. Okay, that's the reason why many deans are actually now going after researchers to publish in some of the top journals in their areas. In USM now, we recently had a change of the VC, and we have now a VC who is very young, 44 years old. 44 years old. Suddenly he came in and he started changing a lot of things. So now a lot of lecturers are actually quite stressed. So the requirement is for a full professor, we have to have 3 publications in SSCI, which is in Q1 and Q2. Q1 and Q2. For those who are associate professors, you need 2 publications in SSCI Q1, Q2. And for those who are senior lecturers, you need 1 papers in SSCI Q1, Q2. That's what we call as ranking, a different ranking. The professors have to actually produce more, and then associate professor a bit lower, and senior lecturer is the lowest expectation. Okay, but unfortunately, we are actually struggling in the social sciences to meet those targets. Although we meet targets, sometimes it's because there are some researchers who produce more, and many researchers who don't do research at all. So that is one of the challenge even in Malaysia. So because of that, what many years ago, when I first started as a lecturer, there was no requirement for publication. But as we started to move towards ranking, we were required to publish. So, and I've been using SPSS for a long time. I think most of you should be very familiar with the software called SPSS, which we have been using for a long time. Okay, but unfortunately, about 15 years back in 2006, 2007, many of the papers that I wrote using SPSS were written by the editors because they asked me to do an analysis called structural equation modeling. But up to 2008, I did not know what structural equation modeling was all about. So in 2008, I decided I also need to learn this technique called structural equation modeling because most of the papers published in the top journals in my area, they were using some form of structural equation modeling. So that is where I started my first stream. This is my journey into structural equation modeling. So the first workshop I attended was with this guy called David Kenny. Okay, David Kenny is considered a legend in mediation analysis. He's considered a legend in mediation analysis. According to the paper called Barron and Kenny 1986, this particular paper has more than 100,000 citation. 100,000 citation. Huh? Okay. So in 2008, what I thought was, since I want to learn structural equation modeling, who better to attend with than the person I've been citing a lot in most of my papers. So Barron and Kenny is actually very famous for mediation analysis using the 4-step approach. Okay, so if we are doing analysis using moderation and mediation, and you don't cite this paper called Barron and Kenny 1986, something is very wrong with the literature. Okay, that's how big this literature was. And it took me 33 hours to arrive at the workshop site. I took a flight from Penang to Changi in Singapore, another flight from Singapore to Frankfurt, from Frankfurt to New York, and then I took a train to Boston. I took a bus to Hartford, and I took a taxi to University of Connecticut. Okay, it took me 33 hours. And then I spent 5 days workshop with David Kenny, and then I returned. Okay, that was the trip, the first trip to US. So during the workshop, I actually learned some of the terms that is very familiar now called latent variable, fit values. Those are the things you need to understand. And one of the workshop I would recommend you to attend is a workshop on structural equation modeling using AMOS. This is where many of the basics about measurement model fit and all is actually originally developed and tested. Okay, so during this workshop, I actually wanted to learn how to run analysis using the measurement model and the structural model. But unfortunately, in the US, the focus is more on the development or the theory rather than the hands-on. Okay, so what happens in a workshop in the US is in the morning, David Kenny will give us the theoretical foundation, and in the afternoon, there'll be a younger person who will give you the hands-on experience. Okay, that's how workshops in the US runs. They don't do hands-on all the way. Okay, hands-on all the way. So that was my first trip to learn structural equation modeling using a software called AMOS. But during the workshop, I actually couldn't understand most of the things I needed, because in reporting structural equation modeling, we will have a table called measurement model, okay, which has loadings, AVE, and the CR. I actually showed a paper to David Kenny and asked him, how do I develop this table? And his answer was straightforward. I don't know. And then he mentioned this. In my area of research, we don't present tables like this. His area of research is clinical psychology. Clinical psychology. But 4:30, I was asking him this question. 8:30, he was sending me some materials. Maybe you want to look at these materials. So the first workshop I attended, I couldn't actually fully understand what structural equation modeling using AMOS was all about. So I have to come back and then relook at some other workshop before I actually started writing my first paper using the software called AMOS. So the second workshop I attended was also in the US. This time it was in Washington, DC. This was with a guy called Gregory Hancock. Okay, the software that is shown at the back in the slide is actually a software called LISREL. Okay, LISREL. LISREL is a software that you can do structural equation modeling in a branch called covariance-based SEM. Covariance-based SEM. Later, I will explain to you the difference between variance-based SEM and covariance-based SEM. Okay, this is a software that is also used for covariance-based SEM, similar to AMOS. But this software is particularly more challenging because you have to write syntax. What is meant by syntax is you have to write coding. You have to tell the software how to measure the variable, which item measures which variable, and then what analysis you want the software to do. then only you will get some output. If there are some syntax errors, that means you have missing comma, missing colons, missing full stops, the software will prompt you and tell you the error line number 30, error line number 43. You have to correct all those errors, then only the output will appear in your screen. Okay, that's how this software works. So this software, although very powerful, not many people like to use this because of the challenge of understanding the syntax. So although I attended this in 2011, I've actually not used the software at all, okay, at all, because we are normally trained to click. Okay, this software, you can't do any clicking. Although now they are actually developing a more user-friendly version based on Windows. Okay, the third workshop I attended was this time in Australia. In Australia, they have an association called ACSPRI. This is a consortium of research method courses that is conducted over 5 days. And they charge a lot. They charge about Australian dollar 2,300 for the workshop. And they have some of the best instructors in Australia conducting the workshop. This is a particular lady called Everada Cunningham. One of the best structural equation modeling workshop was with her. Her materials are really good and her explanations are really good. Okay, if you see, this was in 2010 and we were already discussing measurement, formative and reflective measurement. I still think in many countries, people are still focused on the measurement which is called reflective. Okay, but a lot of papers are now questioning the measurement. There's also another measurement model called formative measurement. You need to also start looking at them because many reviewers are actually raising this issue when you send papers for review. They always ask this question: is your measurement reflective or formative? Okay, you have to first address that before it even goes through the review. Okay, so this was a very interesting workshop that I actually learned most of the basics. So my understanding of most of the structural equation modeling came from this workshop by this lady called Everada Cunningham. So if you have an opportunity to attend workshop, try looking at the workshop offered by this consortium called ACSPRI. Okay, ACSPRI. That was my third workshop. The fourth workshop was with this guy who many people in social sciences and management cite a lot, called Joseph Hare. Okay, Joseph Hare. We cite his book as Hare et al. Okay, Hare et al. He has been. I've been citing his papers from the 1990s, and his multivariate data analysis book is one of the best written and one of the most cited. That book alone has 130,000 citations. Okay, so for those who are doing multivariate data analysis, the book by Hare called Multivariate Data Analysis is considered the Bible. Okay, we have also books like Tabachnik and Fidel, which are much more difficult to understand, but the books by Joseph Hare, they are much more easier to understand and grasp. Okay, so I would recommend you to read those books. Okay, in the materials I shared, you have a folder called ebooks. Most of the ebooks you need is already there. Whether you want to read it or not is a different story. Okay, so you can't claim that you don't have a book to read. His book the latest book was in 2010, but recently they have an update 2018. Okay, multivariate data analysis. So for this software called Smart PLS, the book written by him called PLS Primer in 2014 and updated in 2017 is considered the manual for the software called Smart PLS. Okay, for the software called Smart PLS. So when you buy the software, they only provide you the license. There's no manual. Okay, the manual is actually the book written by Hare et al. In 2014 and 2017. Okay, if you have any doubts about structural equation modeling using Smart PLS, you can also consider sending Hare and email. He also replies to email. He's quite a nice professor. With his stature, he actually does not have to reply questions to everybody. But he does that. Okay, so you can try that. So if you have an opportunity to attend a workshop with him, try doing that, because his explanations are quite clear. Complex statistical issues, he can explain in simple English words, which I find very interesting. This is a conference which is organized by UITM in Malaysia. And here came for 2 workshops. First one was in 2012. And the second one was in 2015. In 2012, he did a workshop on structural equation modeling using AMOS. In 2015, he actually offered a workshop on structural equation modeling using SmartPLS. Okay, so currently he's actually the person cited a lot for this software called SmartPLS. So the book I was referring to is this book called A Primer on Partial Least Square, Structural Equation Modeling, 2014. They have already updated in 2017. They are actually supposed to come out with the 3rd edition soon. But they have not announced it yet. Okay, they have not announced it yet. So, and this was in 2018 when Hare came to visit my department. So he was in Singapore for some visit, and then he wrote me an email. I would like to visit Penang. So I actually hosted him in Penang. He gave a talk for 1 hour on how to publish. Okay, how to publish, which was very interesting. We had a full house. Many people from different schools actually attended, and some of my PhD students. This is my PhD student who's now working in the graduate school called Ali, and this is my graduate student called Dr. Jasmine, who's now working in the same department as me. Okay, so they had an opportunity to bring Joseph Hare around town for sightseeing. So that was 2018. Okay, 2018. In 2013, I actually went to Philadelphia to attend workshop with these 2 guys called Preacher and Hayes. This is Christopher Preacher. This is Andrew Hayes. Okay, Andrew Hayes. These are the 2 guys who actually criticize the mediation analysis developed by Barron and Kenny. So since I've already attended the workshop with David Kenny, I wanted to attend this workshop to understand better why they are criticizing the method. Okay, and Andrew Hayes is a guy who developed a macro call process that you can now add on to your SPSS to do more advanced analysis directly in SPSS, which are called moderated mediation, mediated moderation, serial mediation, multiple mediation. All of them can be done with SPSS directly. One of the limitations is still in SPSS, we have to take scores. Okay, that is one of the limitations still available. And the other problem will be you can only test one dependent variable at a time in the software called SPSS. Okay, in the software called SPSS. Okay, for this guy called Christopher Preacher, he does a lot of structural equation modeling. He believes in using theory for research, whereas Andrew Hayes does not believe in theory. I actually asked him a question and he said, let the data tell the story. So his models are really complicated, very difficult to explain using theory, whereas Christopher Preacher, he begins with theory, so which most of us do. And he's also quite known for a technique called hierarchical linear modeling. Okay? Hierarchical linear modeling. The way we collect data, most of us are exposed to a data collection method where we use a single questionnaire for all variables in our data. And that is now being questioned by many reviewers. Okay? We will also talk about that issue called common method bias or common method variance. Common method variance. So these are some of the workshops I attended to understand better the difference between structural equation modeling and the first generation analysis, which is SPSS. So what is structural equation modeling? This is the definition of structural equation modeling. Structural equation modeling is a family of statistical model that seek to explain the relationship among multiple variables. The key term is relationships among multiple variables. Okay. They also consider items in your questionnaire as variables. So that's why they call relationship among multiple variables. So what the software will do is it will examine the structure of interrelationship expressed in a series of equations, similar to multiple regression. But the only advantage in structural equation modeling is all these equations will be tested simultaneously. Whereas in SPSS, you can only run one equation at a time. Okay. In structural equation modeling, we can run them all together. So the other strength of this method is we have a differentiation between measured variable and latent variable. Okay, the term used is unobservable or latent factor. Okay, what is meant by unobservable is this. So in our research model, we will have a variable called x, which is measured by x1 and x2. We will have a variable called y, measured by y1 and y2. These are the items we collect in the questionnaire. These are the items we collect in the questionnaire. But what we want to test here is the relationship between the independent variable, which is x, and the dependent variable, which is y. Okay, which is y. So the circle is called unobserved or latent variable, and the square boxes are called observed variable or manifest variable. Those are the terms used in the literature. Okay, so that's the difference between observed and unobserved variable. Okay, so in the literature, you will also see this term used a lot. No? Many researchers will say, I use structural equation modeling because it's a second generation technique. Okay, the other confusion many people have is when you talk about structural equation modeling, people always equate structural equation modeling to a software called AMOS. Okay, AMOS is a software. Structural equation modeling is a technique similar to your SPSS. SPSS is a software. The analysis you do in SPSS, we call them factor analysis, regression analysis. Those are techniques. Okay, so you have to know the difference between a software and the technique that you are using. Okay, don't use them interchangeably. Okay, what is the difference between the first and the second generation technique is when we do regression, we need to regress the variable called x against the variable called y. Okay, but in our data collection, we don't have x, we don't have y. Okay, what we have is x1 and x2, y1 and y2. Those are items we collect in the data. Okay, we have to come up with the score for x. We have to come up with a score for y. Okay, so this is where a term called summated scores came into the literature. Summated scores. Okay, so summated scores can be in two forms. One is you take the average of these two items to become the score for x, which we look at mean values. The other summated score you can do is sum. You take the sum of these two items. So if the answer here is 3 and 3, the sum score will be 6. The mean score will be 3. Okay, that's what we call as summated score. So for all first generation software, you have to do this procedure manually to get the score before you move on to the next stage of analysis called regression analysis. That is why those software that you have to do that procedure, we call them first generation. Whereas in second generation techniques, you don't have to do that. The software will calculate the score, but the scores are called latent variable scores. Latent variable scores. So they are actually very different. Later I will explain what are the main differences. Okay, one of the biggest limitation in this first generation analysis is if your loadings here is 0.9 and the loading here is 0.5, they are still treated as equal. This will lead to loss of information. Okay, loss of information. That is why this technique has been criticized in the literature for a long time now. So for the difference between the first and the second generation analysis, in the first generation analysis, we will use cluster analysis, exploratory factor analysis, multi-dimensional scaling. These are for primarily exploratory analysis. For confirmatory analysis, we can use analysis of variance, logistic regression, multiple regression, and confirmatory factor analysis. For second generation, we now have two variations. One is called the variance-based SEM here, and the covariance-based SEM here. So these are techniques. So the software under variance-based SEM, we have SmartPLS, we have WarpPLS, we have Adanko, and so on. Whereas for covariance-based SEM, we have software like Amos, Lizrel, and the rest. Okay, the rest. So what is the main difference between your first generation and second generation analysis is, okay, when you run your first generation analysis, we will run a factor analysis. We call them an exploratory factor analysis. The reason is this. So when we run exploratory factor analysis, we will take these two items from X, these two items from Y, we put them in the analysis, and the software will give you which item falls into which factor and how many factors you have in the model. Okay, that is decided by the software. That's why we call them exploratory. Whereas in confirmatory factor analysis, we are actually telling the system that X is measured by X1 and X2, Y is measured by Y1 and Y2. Okay, Y cannot go to X, X cannot go to Y. Okay, that is why we call them confirmatory. Whereas in exploratory factor analysis, X1 can load into Y and Y1 can load into X. This is not possible in confirmatory factor analysis. Okay, in confirmatory factor analysis. So that is the first difference between first generation and second generation. Okay, the second difference is what we call as measurement errors. Measurement errors. So when we do averaging in SPSS, when we take the average of X1 and X2, we assume X is measured without error and Y is also measured without error. But in your research method classes, normally they talk about sources of measurement error. Sources of measurement error. We have four sources. Number one is the respondent. Number two is the instrument. Number three is the measurer. And number four is the situation. These four will always induce some forms of error. So that is what is included here called E2. This is called measurement error. Okay, measurement error. So the measurement error is actually functional to your measurement quality. If your measurement quality is not very good, your error will go up. Okay, your error will go up. So that's how these two is correlated. So the error plus the measurement will give you a value of 1. Okay, value of 1. So that's measurement error is now incorporated into your analysis, which was not possible with SPSS. Okay, we also have an error term here called E5, which is called a residual error. This is actually normally incorporated because you have many independent variables. You are not using all the independent variables. So that's why you need the residual error. This is not possible in a software called SPSS. Okay. And the third one is traditional methods use observed variables, whereas structural equation modeling can use both unobserved latent variable and also observed variables. And the most important reason why many people are moving to structural equation modeling is this. When we do structural equation modeling, we can test the model as one complete model. So if you draw a model like this, how many equation how many regression do you need to run without the mediation? No? Okay. How many equation you need to run in SPSS? Yes, anyone?
Eight, Prof.
Yeah. How many regression you need to run?
2, 4, 6, 8,
In SPSS, I think it's 8.
9.
No mediation, no mediation. No?
Nine equations.
How do you get 9? Okay. When you run regression models, these are the 3 independent variables. This is the first dependent variable. So this is one regression. 3 independent variable to the second dependent variable plus this. Okay. The first one is this x1, x2, x3 to m, right? This is your first regression. Then x1, x2, x3, and m2 together to m1. This is your second regression. M1 and M2 to Y will be the third regression. So you have to run minimum 3 regression analysis before you can conclude. Okay. So this is one of the biggest criticism to the software called SPSS. You drew one model, but you're actually testing 3 different models. 3 different models. Okay. That's one of the reasons why many people who have mediators and multiple dependent variables are actually moving to structural equation modeling. Okay, any question on this?
No, Prof.
Okay, yeah, okay. So we also have a lot of debate about this issue called confirmatory factor analysis and exploratory factor analysis. So what I've done, this is one of the latest slides I've developed, where I actually put the citation and also a copy of the first page of the papers. So every time I do workshop, the students don't remember the name. So I put the name and also a copy of the paper. These papers are all available in the folder called reference article. Okay, you can look at the folder called reference article. They're all there. So this paper by Hulan et al. I would strongly recommend you to read carefully. This is a really, really good paper on methodological recommendations. So one of the recommendations they post here is for papers not focused on scale development, use of both CFA and EFA is likely unnecessary. In general, use of CFA is preferred. So most of us now use confirmatory factor analysis as one of the instruments to validate our measurement. Okay, validate our measurement. So if we have problem with examiners who still ask, why are you not doing EFA? EFA normally is done when you're developing new skills. But if you're adapting and adopting, you don't have to actually do an EFA. Okay, an EFA. For structural equation modeling, we can look at these 2 authors here. The guru for structural equation modeling is this guy called Herman Wohl. Herman Wohl. He had 2 PhD students called Joreskog and Lohmöller. So Joreskog went into what we call as the covariance-based SEM by developing this software called Lisrel. So all the other software in this category, they actually based on this software called Lisrel. So it's all based on Joreskog's work. For those who are in PLS, which is called variance-based SEM, Herman Wohl and Jan Bern Lohmöller, they started looking at how can we develop a software that can test very small samples with very small samples. That's where this technique, PLS regression, was originally developed. Okay, and all other software that is based on PLS were actually derived from the work of Jan Bern Lohmöller and Herman Wohl. Okay, so now we have 2 variations. These are the 2 variations. So you need to understand the differences so that when you do your own analysis, you have to pick one over the other. So the first one, which is called covariance-based SEM, the objective of this technique is to reproduce the theoretical covariance metric without focusing on explained variance. So when you draw your research model, we call them the theory. You collect your data. Now you want to see whether the data fits the theory. Okay, fits the theory. That's where model fit will become very important for this technique called covariance-based SEM. For those who are doing variance-based SEM, the objective is to maximize the explained variance of the endogenous latent construct. This is what we have been doing in regression for a long time. So in this technique, there is no focus on fit. Okay, there's no focus on fit. So covariance-based SEM, there are a lot of measurement of model fit, whereas in variance-based SEM, they don't have much measurement of model fit. Okay, although they are developing at the moment, even the developers of the software is suggesting you should not be using them. Okay, you should not be using them. That's the difference. Huh? So if you are doing covariance-based structural equation modeling, you will run a factor analysis called common factor. This is how the common factor works. We have an independent variable with 3 indicators, and we have 3 error terms. The dependent variable has also 3 indicators with the 3 error terms. So here, when we do modeling, to calculate sample size, we need to calculate how many parameters we will be estimating. So here we have 1, 2, 3, 4, 5, 6, and 7 parameters. So that is why when you do structural equation modeling using covariance-based SEM, you need a bigger sample size. Okay, because the more items you have, the more error terms will be there, and that requires sample sizes which are larger. Many SEM modelers always claim the minimum sample size is 200 for SEM modeling. That's also not true. Huh? That's what I call as deviant teaching. Huh? It actually came from a faulty simulation exercise. Huh? So the number can range from 100 to even 800, depending on how complex is your model. So this is how a common factor in structural equation modeling using AMOS is supposed to be tested. Okay, but what happens is many researchers, when they will begin with this model, but what they will do is they will try to modify when the model does not fit, with arrows from here to here, arrows from here to here, arrows from here to here. These are actually what we call as modification. So when we modify your model, you're already admitting that your theory was wrong. Okay, this is actually now moving to exploratory. But what I see is there are many candidates and researchers doing this without even blinking their eyes. These are actually incorrect. You cannot be modifying the model. If you modify, you have to have strong reasoning. Okay, you have to have strong reasoning. Huh? This is actually given in this paper by Green et al. Huh? This is also another good paper that you should read. Green et al. 2016 in a journal called Organization Research Method. So here they stated clearly, correlating measurement errors in CFA-SEM is almost always bad practice. The only time it is allowed is if you have time 1 and time 2 measurement. Okay, if you have time 1 and time 2 measurement. So this is some of the literature that has criticized the bad practices of correlating error terms. The second paper is by Hare et al. In 2017. And what he wrote was, if correlated error terms are necessary to achieve good fit, the measurement is flawed. Okay, the measurement is flawed. Okay, the third paper is by Goodboy and Klein. Goodboy and Klein. Here also what they say is there is no reason to ritualistically drop every part that is non-significant. This is not theoretically justifiable. Okay, not justifiable. No? Okay, risk specification can be done, but there must be theoretical rationale. Okay, what is meant by risk specification is you introduce new relationship or new correlation between the error terms. You must have a strong theoretical argument. Okay, this is actually not present in many papers. Okay, and the other term they use in structural equation modeling using AMOS is this term called cherry picking. Okay, what is meant by cherry picking is most researchers using structural equation modeling using AMOS, they only report measures which are nice, which passes the cutoff value. Measures which are not so nice, which is below the cutoff value, they don't even report them. That's not good practice. So in each area of research, they will have several recommendations. Researchers should follow those recommendations instead of picking and choosing what to report. Okay, what to report. Okay, this is a recent paper in 2020 by Davetas et al. This talks about structural equation modeling using AMOS. Okay, what they wrote in the conclusion is, as a result, one of SEM's biggest strength, that is identification of models misspecification, has unfortunately become also one of its big weakness, because now people modify them even without thinking. One of the bad things with the software called AMOS is they have a button called modification indices. This will tell you how to modify your model. Okay, how to modify your model. Unfortunately, the software does not know theory. The modification is based on statistics. How to reduce your chi-square. That's all. So this is one of the challenge happening for those who are using structural equation modeling using AMOS. Okay, you have to have a model to fit the measurement model and the structural model before we can test the relationship. Okay, before we can test the relationship. Okay, this is the paper I was mentioning to you called Davetas et al. So here they wrote this. Development of data-driven models that cannot be theoretically justified and would rarely replicate on different samples. This is the conclusion they have made. So the modification that you follow, suggestion from the software, is actually not justifiable. Okay, not justifiable. But you can see many researchers and many PhD candidates who do modification even without thinking. Okay, that's bad practice. That's bad practice. So this is a term coined by Ronald Coase. If you torture the data long enough, it will confess. So there's a term now used in the literature called hacking and hacking. What is meant by hacking and hacking is, hacking means you modify your data or you delete your item until your relationship becomes significant. That's called hacking. Hacking is hypothesizing after the result is known. You start with a bigger model, let's say 10 variables. Variables which are not significant, you drop from your model. Finally, you find 5 variables which are significant, and you state that this is my model. You don't say that you started with 10, you ended with 5. Okay, that is called hypothesizing after the result is known. These are actually not good for science. Not good for science. Yeah. Okay, for those who are doing structural equation modeling using variance-based SEM, we actually follow a factor analysis called composite factor. Composite factor. So what is meant by composite factor is the error terms are actually correlated. So when we do sample size calculation for models like this, we don't have to estimate error term 1, 2, and 3. We only need to estimate loading 1, loading 2, loading 3, and also the correlation. So just now we had 7 parameters. Now the parameter has reduced to 4. So that is why structural equation modeling using variance-based SEM works with smaller sample compared to structural equation modeling using covariance-based SEM. Any question on the difference between variance and covariance-based SEM? Yes, any questions? Okay, since there are no questions. Okay, for selection of the software to use in covariance-based SEM, most researchers use these two softwares, AMOS and Lizrel. Okay, AMOS and Lizrel. AMOS is very popular in this part of the world, Southeast Asia, Taiwan, maybe. Okay, Lizrel is very popular in the US. Okay, in the US. One of the reasons why many people like this software called AMOS is it is graphical user interface. Just draw some arrows, draw some circle, put some arrows, it will work. No? Whereas Lizrel, you have to learn about syntax. Okay, these softwares are all commercial. No? These are all commercial software. The one free open access is the last two, Lawen and Oinks. Okay, Lawen is the one now getting a lot of response on the internet. No? So they have this freely available software called Lawen, and they also support the development of new techniques using this software called Lawen. You can also try this, okay, if you want to. For those who want to go into structural equation modeling using variance-based SEM, the most popular software is now SmartPLS, and the competitor is this software called WAP-PLS, and another software called Adanko, which was developed by Jörg Hensler. Okay, Jörg Hensler. Okay, so this software called SmartPLS, they have licensing schemes. Okay, if you install for the first time, the software is called student version. Okay, a student version. Student version is free for life. Unfortunately, they have some limitation. Student version can only analyze 100 cases and below. 100 cases and below, and you cannot copy and paste the output. Okay, you can only look at them or print screen. You cannot directly copy and paste into your report. If you right-click to copy, they will tell you go and buy the license. Okay, so that is student version. For our exercises, we need the full professional version. So for those who have installed for the first time, you can request for a trial license. Okay, you can request for a trial license, which gives you 31 days access to the software, full version of the software. Okay, so how the license works is the first day you install, they will show you 31 days available. So tomorrow it will become 30, and the next day it will become 29. Once it reaches 0 days, it will go back to the student version. Okay, your data project is still available, but if your data is more than 100, the software will not be able to open the analysis. It will tell you you have too many cases. Okay, that's the first version. So if you are not interested in buying a full license for a year, 1 year is 366 days. That will cost you 440 euro for professionals. For academics, we have a 50% discount. So it is 220 euros. Okay, 220 euros for a 1 year license. Okay. If you don't want to buy a license for 1 year, you can also buy a license for 1 month. Okay, 1 month. 1 month is 31 days. They give you the license for 22 euros. 22 euros. Okay, that's the licensing information. Okay, later we will look at your software, whether you have the full version or the student version before we start our hands-on. Okay, any questions on the licensing format? Yeah, Abid, any question? Yeah. Okay, so for those who have already used the trial license before, during the break, I will provide you with a 2-month license, which you cannot share. You can only use for yourself on one PC. Okay, again, you can use, I will share with you a license key, which can be used for one PC. They will give you 62 days access, which is already 44 euros, which is already saving you 44 euros. But I will provide you a bit later. Okay, but you should not be sharing the license key. Okay, if you want to share the resources, is okay. That's why I separated the license key from the resources. Okay, yeah. Any question? Okay. So the other issue you will have is why you choose PLS. This is one of the questions that gets asked a lot in Viva Voces, because many of the examiners are actually well versed with covariance-based SEM, whereas variance-based SEM is something new in a country like Malaysia. So here they give you the description. So in general, two applications of PLS are possible. It can either be used for theory confirmation or theory development. Okay, both can be used, theory confirmation and theory development. And these are some of the reasons given in papers published prior to this. Okay, this is a good paper to look at the difference between covariance-based SEM and variance-based SEM. So these are 6 reasons given in the literature. Some of them are no longer acceptable, so you need to know them. Number 1 is PLS makes fewer demands regarding sample size than other methods. This is the most abused requirement in Smart PLS and PLS. Okay, many researchers write in their papers, I use Smart PLS because my sample size is small. Okay, so if you write a paper like that, if I am the editor, I will tell you, thank you very much. We don't need a paper like that. So you don't begin with a small sample size. It is always recommended to collect bigger sample sizes because bigger sample sizes are more representative. Okay, more representative. Okay, unless your population is small. Say, if your population is only 200 and you want to run an analysis with 80, then there's no other software that can do that except Smart PLS. Okay, if your population is small. No? Other than that, you don't begin with small sample size as your reason for using the software. Okay, that's number 1. No? Okay, number 2 is normal distributed input data. Okay, one of the requirements for using structural equation modeling using covariance-based SEM is data must be normally distributed, failing which you have to move to non-parametric analysis. So Smart PLS is actually a non-parametric structural equation modeling. So the number 2 requirement is also not a good reason for you to choose Smart PLS, because in AMOS now they also provide what we call as bootstrapping. Okay, bootstrapping. So if your data is not normal, you can bootstrap your distribution. So you cannot use this second reason also for choosing between covariance-based SEM and variance-based SEM. Okay, number 1, number 2. Okay. Number 3 is PLS can be applied to complex structural equation modeling with a large number of constructs. This is one of the reasons why in Malaysia, many PhD students use Smart PLS, because the models that they have are really, really large. Okay, they make the model as big as possible with moderation, mediation. So when your models are very large, then you have a problem with the technique called structural equation modeling using covariance. Okay, that will not cater for large models. Okay, how do you define large models? Here has a justification: 7 constructs, 50 items or more. Okay, 7 constructs, more than 7 constructs, and more than 50 items. They are considered large models. Okay, large models. So if you have that kind of model, then the choice will be clear, which is Smart PLS. Okay, number 4 is PLS is able to handle both reflective and formative construct. Okay, most of the analysis you see in SPSS and AMOS, they consider measurement to be reflective. But we also have now a measurement which is called formative, which I will discuss. If you have both reflective and formative, then your choice is very limited. Okay, your choice is very limited. Okay, the third one is PLS is better suited for theory development than theory testing. Okay, what is meant by theory development is you start with a new theory, you start with an original theory, but you modify the theory by including some new variables from the literature. Then you are actually now into theory development. Then smart PLS will be more suitable. And the last one is PLS is especially useful for prediction. No? So now we have also a lot of literature on prediction. Okay, so PLS is considered prediction-oriented software. So later I will also show you how to assess prediction accuracy. Okay, so if you want to predict some dependent variable, for example, if you are doing critical success factor studies, then this software is the right choice. This software is the right choice. Okay. Any question on these 6 choices? Huh? How to make decision based on these 6 choices?
No, Prof.
No question. Huh? Okay.
Yeah, it's clear.
Okay. This paper by Hulan et al. 2018 also talks about this issue of sampling. Huh? We also have a lot of debate and argument about sampling. Huh? When you do structural equation modeling or statistical modeling, you must have a random sample. That's also a misguided or misunderstood issue. Huh? You don't need a random sample. Huh? What you need is a representative sample. Okay, a representative sample. Huh? So here in the 2018 paper by Hulan et al., what they stated was, when the primary aim of the research is to test the veracity of proposed theoretical effects, the use of a convenient sampling may suffice. Okay, and the consideration for theoretical effect testing is to select measurement objects and a research context in which the hypothesis can be meaningfully tested. So the choice of respondent is more important in testing theoretical effect. This is what we are doing most of the time. Okay, we are doing most of the time. Huh? So you don't have to worry about this issue of random sample. Okay, random sample. Huh? And this is a paper in 2019 by Merton Cross. Huh? What he wrote here is randomness is problematic for social science research, and they have argued this. Huh? Okay. Random chance is a mathematically elegant notion that is logically inapplicable for social science empirical research purposes. It nevertheless has been widely used to evade rather than solve some critical problems of current social science research methodology. Huh? So what they wrote was this random sampling is merely statistically finessed by making unjustifiable randomness assumption. So because of that, we have a lot of problems we cannot solve because we cannot do random sampling. Okay, so for those who have a problem with debate about random sampling, non-random sampling, the 2 papers I shared called Hulan et al. 2018 and this paper by Cross in 2019, they are really good for justifying the non-random sampling. Okay, yeah, okay. And in this Hulan et al. 2018 paper, they also talk about this. Many of the papers published in the top journals, they use convenience samples. Okay, convenience sample. Huh? Yeah, the other good thing about this paper by Hulan et al. Is they talk about some practices that researchers follow ritualistically. Yeah? Okay, one of them is called response bias, non-response bias. I think many people like to use the paper by Armstrong and Overton for this analysis called non-response bias. But what they argued in this paper is when you don't have an obvious target population, this non-response bias test is actually not required. Okay, not required. No? So again, this paper is a very good paper for you to read on methodology. Okay, I was talking about complexity, right? This is the kind of model some of our MBA students do. But if you see this model, it looks very complex, but there's nothing much new in the model. So we call this a plug and play model. No? I'm still trying to get this paper published already about 2 to 3 years. Still struggling to get the paper accepted. Okay. For a PhD, we have models like this. If you have models like this, it will be nearly impossible to get a model fit in structural equation modeling using covariance-based SEM. Okay, covariance-based SEM. So this is only to show the difference in complexity. Okay, the other problem you will face when you use partial least square SEM is there's also some bias with editors. Some editors actually don't like this technique called partial least square. So if you send to those kind of journals, they will tend to reject. Okay, you don't have to worry about that because what now the developers are doing is they are also publishing in the top journals so that to say that the technique has no flaw. Okay, what they do is they cite a paper by Ronco. Mikko Ronco is one of the authors who like to write criticizing paper about PLS. Okay, PLS. Okay, so but there are a lot of papers which has also counter argument to this debate by Mikko Ronco. Okay, Mikko Ronco. So you can look at them. Yeah. Okay. This paper by Gerbing also gives you this guideline for selection. In situation where prior theory is strong and further testing and development are the goal, then covariance-based full information estimation methods are more appropriate. So if your area don't have very strong theory, and if the area is evolving, then use of smart PLS is more suitable. That's what the paper is saying. Okay. Yeah. Yeah. Okay. Yeah. This one. This paper by Reynolds et al. In 2009. What they wrote was most of the time when we develop model, we have an interactive character. That means we will have a model already based on prior theory. We will add new measurement or new relationship to the model. Okay, that is what we call as incremental study. Okay, incremental study. Yeah. So for a comparison between PLS and covariance-based SEM, you can look at this paper by Urbach and Ahleman, 2012, I think, 2010 or 2012. Okay, they put these two techniques side by side and they give you a comparison. The three most important ones are the one highlighted here. For model complexity, covariance-based SEM only can cater for small to moderate complexity. And then they give you an example, less than 100 indicators. Whereas for partial least square SEM, you can accommodate models which has 100 constructs and 1,000 indicators. Okay, so that's the difference between complexity. Sample size for partial least square SEM, it ranges. We will do some power analysis. I will show you how things can be done. Okay, 30 to 100. Whereas for covariance-based SEM, the sample size can go from 200 to 800. Okay, 200 to 800. Okay, the third important one is called optimization. Okay, we have two types of optimization. One is called locally iterative, and the other one is called globally iterative. What is the difference is locally iterative means they will try to maximize one variable to another variable relationship, okay, which is called component-based modeling. One independent variable to one dependent variable, then they move to the second independent variable, third independent variable, and so on. While in covariance-based SEM, the model must fit together. All variables must fit together as a theory. Okay, so if you have one variable not very good, the whole model will fail. Whereas in PLS, we don't have that problem because if one variable is not so good, it only affects that particular relationship. The rest of the model is not affected. Okay, it's not affected. Yeah. Okay. Yeah. Any question on this before we move on? Yeah. Any questions? Next, we'll look at the development of a partially square SAM and the use of this software called Smart PLS. Huh? Okay, these are the two guys I met in 2011 to learn my structural equation modeling using Smart PLS. Huh? Okay, that was the first time I started picking up Smart PLS. Huh? That's about 10 years ago. Huh? Exactly 10 years ago. Huh? And the developer of this software called Smart PLS is Christian Ringler. Okay, Christian Ringler. Okay, on the left hand side. This is Christian Ringler. So he has kindly provided the Smart PLS license, which I will share with you. If you buy it from the company, will cost you 44 euros. 44 euros. But this you will get it for free. During the break, I will share with you. He developed this software in 2005, which was Smart PLS 1 and Smart PLS 2. Smart PLS 1 and Smart PLS 2 was free. Smart PLS 3 was chargeable, because now they have a big team working to improve the software. So many new analysis has been introduced recently. So that is why now they're actually charging. They're actually charging. So the other guy who is also a very big name in structural equation modeling using PLS is this guy called Hensela, Jörg Hensela. Okay, both of them were together when I went for the workshop in November 2011, but they have already gone different ways. Ringler is still with the software called Smart PLS. Hensela has actually now started another software called Adanko with a guy called Theo Dijkstra. Theo Dijkstra. Okay, I will show you the person he has started to work with. Okay, so that was my first workshop. And 2015 we actually met in Sevilla. Okay, in 2005 when they launched Smart PLS 1, they had a workshop or conference for that launch of the software, and they didn't do any conference until 2015 was the second one, which was in Sevilla. 2020 was supposed to be the third conference in Beijing, but unfortunately because of the pandemic, it has been postponed to 2022. Later I will show you the call for papers. You may want to look at it. So this was in 2017. After that meeting with Ringler in 2017, we started working on this paper for a joint paper in a journal called Tourism Management. Tourism Management. This is one of the top journals in tourism. Okay, and for a software called WattPLS, you may want to look at this guy called Mustafa Rasuli Manish. He writes a lot of paper using the software called WattPLS. Okay. Okay, this is Jörg Hensela. He's very strong mathematically. In 2012, I think Mikko Ronko wrote a paper criticizing PLS analysis. In 2013, Hensela actually wrote a reply saying that the way you look at things are totally wrong, and that was the rebuttal. So that 2013 paper, which was published in Organization Research Method, is one of the most highly cited paper in that journal. Okay, you may want to refer to that if you have a question about criticism to partial least square analysis. Partial least square analysis. Okay, the other guy who you will cite a lot also in your literature is this guy called Markus Sasten. This is one of the strong modelers in Smart PLS now. Okay, why I said he's a strong modeler is in 2018 he had 5 Emerald Literati Award in 1 year. Okay, to get one in our lifetime also we are struggling. But he has 5 in 1 year. Okay, that's really amazing achievement for a young guy. He's about 40 now, I think 40 years old. Okay, so you will cite a lot of his papers when you start writing papers using partial least square. Okay, partial least square. You can also explore opportunities to work with him, maybe in the future. He's a very nice guy to approach. Okay, very nice guy to approach. Okay, so I will skip this. Later I will talk about this conference. Okay, and okay, we had a joint paper in 2018. This paper is now highly cited for an analysis called redundancy analysis. Okay, for those who want to do formative measurement, one of the analysis required is called redundancy analysis. So what we did was we actually tested the redundancy analysis with a single item and a multiple item measure. And what we concluded was, based on the simulation, a single item works well. Okay, single item works well. So this is the paper now cited for those who are doing formative measurement. Okay, formative measurement. So the other person you will cite a lot for second order analysis or higher order components is this guy called Jan Michael Becker. This is one of the youngest person in the team. Okay, he just finished his PhD, did his postdoc, and now started on his first job. Just started. Okay, a very young guy. So if you are doing hierarchical component modeling, okay, hierarchical component modeling, you will cite Becker's paper, which is 2012, long range planning. Okay, long range planning. This was a conference we had in 2015, where the keynote speakers were Rigdon, Dijkstra, Chin, and Hare. Okay, so I went to this conference to meet the other three people. I've met him a couple of times, so I wanted to meet Rigdon, Dijkstra, and Chin. So this conference gave me that opportunity. I presented a very simple paper, and then this is Ed Rigdon. He's a very famous structural equation modeling using covariance-based SEM, but now he's a strong proponent of SmartPLS. So he's written a paper in 2012 in praise of simpler method. Okay, in praise of simpler method, where he explained why PLS is much more easier to develop and understand. Okay, develop and understand. Okay, Dijkstra is another person you will cite. He developed the software called Adanko together with Jörg Henselaar. And now in SmartPLS, we also have a new technique called consistent PLS. Okay, this consistent PLS was developed by Henselaar and Dijkstra. Okay, if you want to do confirmatory modeling in SmartPLS, then you should be using the technique called consistent PLS. Okay, consistent PLS. Unfortunately, I'm not very sure whether there will be any more development because I think Dijkstra passed away last year. He passed away. Okay, so I'm not sure whether there will be new. Okay, this is the other guy called Win Chin. I've been citing him from the 1990s. Chin WW. Okay, one of his famous papers is Chin 1999. Okay, 1999. That's a very highly cited paper. He has been writing about partial least square analysis for a long time. But unfortunately, many people are citing Hare's book as the source. He's also not very happy with that. Analysis like orthogonalization in moderation and redundancy analysis was originally developed by Win Chin. So you may also want to explore papers written by Chin for your own justification in your model. Okay. During the Sevilla conference, we had a pre-conference and a post-conference workshop. We start 9 a.m. in the morning and finishes at 9 p.m. in the evening. The basic workshop was conducted by Hare and Ringler. The advanced workshop was conducted by Henselaar and Sasted. Okay, Henselaar and Sasted. Okay. And Ringler also comes quite often to Malaysia. These are some of the workshops he does in Malaysia. He works with a school called Graduate School of Business in UKM, University Kebangsaan Malaysia. In 2011, when I took my sabbatical leave, I actually went to the University of Melbourne for my sabbatical leave. For academics in Malaysia, public universities, we can get 9 months off after you serve 5 years. Every 5 years, you can get 9 months off, or every 3 years, you can get 5 months off to go anywhere you want. Your salary will be paid in full. You don't have to do any teaching. So you can travel to any part of the world. So this was my first sabbatical in 2011. I actually traveled to University of Melbourne to meet this guy called Peter Seddon. Peter Seddon was a senior editor of a journal called MIS Quarterly for 5 years. Okay, that is the reason why I went to Melbourne to meet this guy. But I didn't do my sabbatical with him. So if you see at the back there, he's actually doing a workshop for PhD students, telling them how to interpret the output from papers. Okay, so what he does is every Friday they have a session from 3 p.m. to 4 p.m. He will lead the discussion, and all PhD students will attend. Okay, and then discuss. And this session is really lively. Unlike many sessions with PhD students, when you ask them any question, there's no question. Here you just open your mouth, any question, there'll be a lot of questions. And they don't have to call you professor or doctor. They just call you by name. And you can see in this session, some PhD students will tell him, Peter, I think you are wrong. This is why I think you are wrong. Okay, this is not possible in many other countries. Like, okay, even in Malaysia, that's not possible. If you say like that, then the rest of your life will be miserable. Okay, but in Australia it's different. They have actually very open discussion, and after the discussion we will go for coffee, and then that's the end. We don't remember what we have discussed. Okay, that's a system they have. So when I was in University of Melbourne, Peter actually came to see me one of the days and told me, I will take you for coffee tomorrow at 3 p.m. The whole day I couldn't sleep. And then he asked me a question during the coffee. How many we were discussing about the PhD system in Malaysia and Australia. In Australia, they don't have a viva voce. They only have, you submit your thesis, they send to 2 reviewers. If both reviewers are positive, then you get your PhD. If both reviewers reject, then you don't get your PhD. If you have 1 positive, 1 negative, they will invite a 3rd person to decide whether you will pass or not. That's the system they have in Australia. Whereas in Malaysia, we will appoint 2 internal examiners, 1 external examiners. And during the viva, you are expected to present. And then you will have a viva voce where the internal and external will ask you questions and decide whether to pass you. Okay, that is not possible in Australia. And then he asked me a question: how many PhD students do you have? And at that time I had 12. So when I told him I have 12 PhD students, he told me this: Ramai, are you joking? Are you running a factory in Malaysia? Okay, but in Australia you are only allowed up to 3 PhD students at any one point of time. You cannot take more than 3 PhD students as a supervisor. But in many developing countries, they don't have a camp. It depends on the numbers. In some schools, we have many candidates. So some supervisors end up supervising many PhD students. Okay, that's one of the challenges in developing countries. So this was the 3 months I spent at the University of Melbourne. Very, very interesting 3 months. I actually learned a lot. So if you have a system where you can go on your sabbatical leave, you should consider taking the sabbatical leave. Okay, that's actually a break, and you can go and visit people and get the networking going. So I'm still working with my host in Melbourne until today, writing papers and joint grants. Okay, joint grants. Yeah. Okay. If you see here, this is a paper written by Venkatesh et al. In 2003, 2012. This is called UTAUT. Okay, UTAUT2, I think. UTAUT2. Peter Seddon was the accepting senior editor for this paper, okay, at that time. So this paper is also one of the papers highly cited for technology adoption, okay, technology adoption. Okay. So 2011, I went to visit him in Melbourne. 2014, we were actually sharing a session in University Malaya. Okay, he was running the qualitative track, and I was running the quantitative track. So that was how this 2014 workshop went. We had a good discussion during the final day, where he actually we were allowed to ask questions. So I actually asked him a question. Is there an Indian clan in MIS Quarterly? Because you see, those who publish in MIS Quarterly are actually Indian origin. Venkatesh Bala, Subramani, okay. But his answer was quite interesting. He said, there's no clan in MIS Quarterly. But what these Indian authors do is, before they write the paper, they actually write to the editors what kind of methods they like, what kind of topics are they interested in. Then only they do their research. So they're actually doing their homework before writing a paper. What we normally do is, we write the paper and then push to journals. Okay, so it can work both ways. Sometimes you get lucky, the paper gets accepted, but most of the time, it depends on the editor if he likes the topic or not. Okay, he likes the topic or not. Yeah. Okay. Okay. For those who want to go into this software called WAP-PLS, this is a guy called Nat Kok who developed the software called WAP-PLS. So in 2017, we had a PLS conference in Macau, where he attended. So, and then he actually came to USM for the workshop. Okay, and this software is quite powerful. Okay, WAP-PLS. But unfortunately, not very user-friendly. Okay, not very user-friendly. So for those who have problems with moderations or multiple mediation, you may want to consider this software called WAP-PLS. So we actually wrote a joint paper in tourism management perspective, which is also co-authored with Mustafa. We originally submitted to tourism management, but somehow the editor, Chris Ryan, after the second revision, he said, I'm going to reject this paper, but I will offer you this journal called Tourism Management Perspective. At that time, it was only in Scopus. Now it's already in SSCI. Okay, they have the same editorial board as tourism management. Okay, tourism management perspective and tourism management. Earlier, the chief editor was Chris Ryan. Only recently, Chris Ryan left his post as the chief editor. Okay. Yeah. Okay. For those who are doing mediation analysis, you may want to explore papers written by this guy called Jose Luis Roldan. Okay, Roldan writes a lot of papers on mediation, and is quite highly cited for that analysis called mediation. He writes in journals like Journal of Business Research, Decision Sciences, which is one of the journals I've been looking at for a long time. Okay, those are the kind of journals he's writing in. And for a long time, we have been using two-tailed test for mediation. He has actually written a paper in 2020 where he argues that you can actually use a directional hypothesis for mediation. So tomorrow when we do mediation, I will discuss the paper written by Roldan. Okay, written by Roldan. Okay. Okay. Yeah. We also wrote a joint paper in 2017. In the Journal of Travel Research with the same person, Mustafa. Mustafa was our PhD student in USM, and then he became a postdoc, and then finally became a lecturer in housing, building, and planning. But I think 2 years back, he left USM because he got a better offer from Taylor's University. So currently, Mustafa is in Taylor's University, for those who wants to contact him. Yeah. Yeah. Any question?
No, it was a very exciting session, Prof.
Okay.
It
So
reminded me lots of old stories, old memories.
yeah. So what we will do is we will take a 30-minute break and then we'll come back for the next part. Okay, Abid?
Okay. Yeah.
So it will be what time in Oman?
Now like 11 o'clock.
Okay, so we'll come
11
back at
o'clock.
11.
We'll be back.
Okay, we will be back at 11.
Yeah.
Thank you, Professor Ramai. Thank you. We'll be back in
Thank you.
at
Thank you, Prof.
Okay, I hope everybody is back. So we will continue. The license I put on the chat box is for 62 days. Huh? So it's only for one PC. Huh?
So this is after the trial period?
Yeah. After the trial period, you can copy and paste. You get another 62 days.
Okay, thank you very much. Thank you very much.
Okay, next we'll look at some resources available for you for conferences, books, and so on. Huh? So next we'll look at for conferences. We have several conferences you can plan to attend. One of them is we are organizing this every 2 years. Huh? The first one was in 2017. The second one was in 2019. 2017, the keynote speaker was Sastet. 2019, we had two people, Sastet and Ringler in Malacca. We were supposed to do one in 2020 in Bali, but unfortunately, due to pandemic, it has been postponed. Hopefully this year, if things become better, we will have the third one in October 2021. Okay, that's one of the conference. This is a very exclusive conference only for applied structural equation modeling. So the interaction will be more focused. Unlike many conferences, which is actually very broad area, here it's much more focused. So you get to meet with many of the people who are actually more focused on doing structural equation modeling, which is more applied, not so much on the methodological issues. Okay, but we still have some keynote and some workshops organized along with this conference. Okay, this conference. The big conference is this one, which is in 2022. This will be in Beijing. This is where you will meet all the big names in partial least squares. Okay, the keynote speaker is Joseph Hare. Organizing conference chair is Christian Ringler and Marco Sastet. So most of the people you cite in your literature, they will be there. Okay, this is considered like one of the most prestigious conference for partial least square. Okay, so if you want to meet them, then you can plan for it. Okay, they have a lot of special issues also tied to this conference. So most of them are SSCI journals or SCI journals. So after the conference, you can also get the paper reviewed, and they will identify you for you the journals, and then transfer the paper to that journal. And if the review is good, then you can get published in that journal. So they will have several special issues that you can try. The third conference is the one organized by Netcock in Texas. Every year in April, he organizes this conference without fail. Every year he does that. But this year, last year it was canceled because of COVID-19. This year is still scheduled for April 2021. We have to see how things goes. The first day will be a free workshop on WAP PLS. Second and the third day is the conference. Okay, second and the third day is the conference. So only the first day is a workshop, free workshop. So that's actually a good thing. For me to go all the way to US for 3 days, it's a bit more taxing because of the journey. But for you, maybe it's closer. You may want to think about this. And the fourth one is this organized by Win Chin. Win Chin runs this workshop. Previously, he was doing it every year, but it's moved to 2 years, and now already about 4 years, we don't have any conference he's organizing. But this is also where you can meet all the big names in partial least square modeling. Okay, partial least square modeling. Okay. For books, you have these are the two books that is considered the manual for the software. The first one is PLS Primer, which was 2014, and the second one is the update second edition, 2017. But I would recommend you to read the primer, the first edition, before you move to the second edition, because they have removed some of the materials from the first edition to keep the number of pages, I think, because they don't want to charge more. So they reduce some number of pages. So some of the materials from the PLS primer is already removed. So you may, it is always better to read the first edition before you move to the second edition. Okay. The only difference is in the second edition, they use a screenshot from Smart PLS 3. Smart PLS 3. Yeah? So that's the only advantage. The first book uses Smart PLS 2. Smart PLS 2. Okay. They've already working on the third edition of the book. They are supposed to launch, I think maybe in a couple of months. Hopefully, because they were supposed to launch a Smart PLS 4, but unfortunately, because of the COVID, they have actually postponed the launch of Smart PLS 4. And my personal communication with Ringler is the software will only be available at the end of this year. Okay, at the end of this year. So the new interface and new things will be only available maybe beginning of next year. So at the current moment, the version is Smart PLS 3.3.3. Okay, that's the latest edition. Okay, this is for basic. For advanced PLS, we have this book by Hare et al. 2018, I think. Okay, but if you want to read more on advanced PLS, there's an ebook in the folder by a guy called Garson. Quite simple to follow. He has all the screenshot. Most of the analysis is available except for, I guess, PLS Predict. Okay, PLS Predict is not still there, but I will show you how PLS Predict is done when we do the hands-on. Okay, so that this is a book for advanced analysis. In 2016, we started writing this book for Smart PLS, which is more catered for the Malaysian audience. The Malaysian audience don't want to know the story behind the analysis. They just want to know how to click, how to copy paste, and then report. So the 4 other authors with me were actually PhD students who attended my workshop. And then they suggested, why not we start writing a manual? So that's how we started writing this manual in 2016. The first edition was published by Pearson. We didn't have moderation and mediation in the first edition. Okay, so in 2018, we actually updated the book, second edition. We were supposed to do the third edition, but because of the postponement of the software launch, so we will be delaying this until maybe end of this year or beginning next year. So this is the second edition, which is very easy to use and straightforward. So this is one of the book which is very, we have already printed, I think, the 4th reprint. Okay, we have already gone to 4 reprints because many people are still requesting for the book. And what we did was, in the second edition, we sent copies of the full manuscript to this partial least square modelers to get feedback, and they give us some quotes that we have included in the second edition. Okay, so that's the book, which is only available in hard copy, unfortunately. Okay, yeah. Okay, so for journal, we also started a journal in 2017, which is called Journal of Applied Structural Equation Modeling. Since we started the conference, we thought, why not we also start a journal? And I was the chief editor, and now we have another chief editor who has joined us. So now we have 2 chief editors. One is me, and the other one is Hiram Ting from UCSI. The managing editor is from Pakistan, Mumtaz Ali Memon. He was originally from University Technology Petronas, but he moved back to Pakistan, I think about 2 years back. Okay, so he's now the chief editor, and we have already got Scopus for this journal this year. I think last year, end of last year, we got Scopus index for this journal. So the next issue will be all indexed in Scopus. Okay, So these are some of the editorial board members of our journal. We have Hare, Ringler, Sastet, Netcock, Hensela, Roldan. Xiao Longwen is a big name in China and Taiwan. No? Okay, and then we have Somya Ray. Okay, Somya Ray is an Indian expatriate who's now working in Taiwan. No? He's working a lot on a technique called PLS Predict. Okay, with another lady called Galit Shimiali. Huh? Tomorrow I'll show you, maybe I'll show you when we do the PLS Predict analysis, you can see the lady called Galit. No? Okay, so that's our editorial board. So the review are quite fast. Huh? 1 to 2 months, they will give you a reply, huh? Whether the paper is acceptable, then you do some revision, that's it. No? Okay, and this is one of the issues we had. A paper from Becker, Ringler, and Sastet. So they're actually not only sitting on the editorial board, they're actually supporting the journal by submitting papers. This is a paper written by them. They actually don't have to do that because the level, their publication are at like the top journals in the world, but they still, to support the journal, they have submitted a paper. Okay, so this is a good paper on moderating effect in PLSM and PLSC, which is the consistent PLS. You can look at it. We also write editorials every year. Huh? So we started that in 2017. The first editorial was on the misconception people have on EFA, CFA, random sampling, sample size, those kind of issues. Huh? We wrote 2017. 2018, I think we wrote on mediation, and then 2019 we wrote on moderation, and 2020 we have written on sample size, which is already included in the folder I shared with you. Huh? So what is happening now is we have put all this literature together to say these are the guidelines for sample size, and then you can make a decision based on the available literature. So that's 2020. Yeah? For Facebook support, we have several of them. Number one is this partial least square group. This is a group started by a custom officer who went to do his PhD in Australia by the name of Dr. Effendi. Yeah? Not very active, but they still, you get a lot of questions asked, and there will be some answers to the question posted on this partial least square group. The one very active is this called MySem. So anything to do with structural equation modeling. It does not have to be only PLS. It can be also about MOS. You can post on this Facebook group, and we have all the big names like Ringler, Sastet, Netcock, who are also in this group. So if you have any question you post, they will also reply. Huh? Most of the time I will reply, and you can see them putting a like, then you know they are actually saying that the comment is okay. So you can see that in this Facebook group. So most of the more recent papers published related to method will be posted directly in this Facebook group. So you can join, and the admin will add you in, and then any post they make, they will send you an email. So those are some of the resources on the Facebook. Huh? The third Facebook group is, this is the main admin is Netcock, who this is more focused on what PLS. Any question you have on what PLS, you can post on this partial least square group, which is run by Netcock. Okay, Netcock. But I'm also in this group. There are many people who are also in this group. Huh? This software. Huh? Okay, so those are some of the support you have in terms of material. Huh? In terms of material. Huh? Okay, next I will go through the process of from the developing the structural model up to testing the structural model before we will go to the hands-on. This is where you will get an exposure to the issues you have during data collect, before data collection, during data collection, before data analysis, during data analysis, and during reporting. So this will cover all the issues before we start the hands-on. The hands-ons, you can actually learn from a lot of YouTube videos. But here the why you have certain issues during certain stages, I will discuss them so that you have a clearer picture of some of the issues you need to be prepared before data collection. What I see is many researchers are rushing to collect data and then they get into trouble, they don't know what to do. Okay, this is a common problem I find with many of the posts I get from myself. They have already collected data. I have this problem, I have that problem. So once your design has an issue, you can't do much with your analysis. Okay, the analysis will end up deleting items or dropping some variables to get a better model. Okay, but that is not a good thing. So before you start collecting data, these are some of the issues you need to think about. So that will give you a better picture for your next research. Maybe you have already collected the data. So that will be useful for your future research. Okay, when we specify the structural model, we will draw, we have 4 variables in the model where we put arrows from perceived resources to perceived usefulness, perceived usefulness to attitude, attitude to actual use. And there's also an arrow from perceived usefulness to actual use. So when we draw this model, can we test this model? Yeah, anybody? Can we test this model? Yes or no? Yeah, correct. Huh? Okay, this is what we call as the conceptual model. You put in chapter 2. Okay, you put in chapter 2. Huh? Okay. So when you write paper, also you have a research model, and then that's what we meant by the structural model. Huh? So what will happen is when we do analysis, we will follow this 2-step procedure, which is called testing the measurement model and testing the structural model. Huh? Okay, so I will talk about this here. So we have the term now used in the literature is called exogenous variable and endogenous variable. So the endogenous variable is where you will get an R square. Exogenous variables are considered the independent variable. Okay, so from one stage to another, you'll have independent, dependent, depending on where the variable appears in the model. Okay. So the second one is the step which is important, which is called specifying the measurement model. This is where chapter 3 in most reports will come, or thesis, which is where you will tell each variable is measured by how many items, where do you get them from. Okay, that's where this kind of model appears. So here we have perceived resources with 4 items, perceived usefulness with 6 items, attitude with 3 items, and actual use with 2 items. If you see, the arrows are going from the circle to the indicator. So when the arrows go from the circle to the indicator, we call them reflective measurement. If the arrow goes from the item to the construct, we call them formative measurement. Okay, this is where you have to decide whether you have reflective measurement or formative measurement. Okay, reflective measurement, they have their the assessment is slightly different from formative measurement. Okay, formative measurement. So you cannot use them interchangeably. You have to decide before collecting data, not after collecting data. Okay, not after collecting data. So this is where we have this operationalization of the construct, which is reflective and formative. Okay, for the first one, this is the one most people adopt. This is a common measurement model, which is used for a very, very, very long time. Okay, what it means is construct is here, right? If the construct score is high, all your responses to item 1, item 2, and item 3 will be high. If the score here is low, your response to indicator 1, 2, and 3 will be low. Okay, that is what we call as reflective. Reflective. We have also another measurement which is called formative measurement, where the construct score here is actually 0. The construct score is influenced by the 3 indicators. If all the three indicators are high, then the construct score will be high. If all the three indicators are low, the construct score will be low. Okay, so that's how the arrow depends. Huh? So for a reflective measurement, item 1, item 2, and item 3, they are actually interchangeable. Okay, they are interchangeable. They are supposed to be highly correlated. For formative measurement, item 1, item 2, and item 3, they are not interchangeable. They cannot be highly correlated. If they are highly correlated, you run into a problem called multicollinearity. Okay, multicollinearity. So that's the difference between the first and the second one. So here we have an example of reflective measurement. Timeliness. Okay, if a person is very timely person, his answers to X1, X2, X3 will be high. If he's not a timely person, his response to X1, X2, X3 will be low. So that's why the arrow is going this way. The score is actually reflected in the indicators. We call them reflective. Here we have life stress, which is formed by 3 items. Job loss, divorce, and recent accident. Job loss, divorce, and recent accident, they are not supposed to be correlated. But if you have all 3 at the same time, life stress will be the highest. If you don't have all 3, life stress will be the lowest. So this is where the formative measurement comes in. And they are not interchangeable. Okay? They are not interchangeable. Here they are interchangeable. Here they are not interchangeable. Okay. Okay. For formative measurement, also in the literature, we have 2 ways of visualizing formative measurement. One is called composite. The other one is called causal. If you visualize your measurement as composite, you should not be deleting any indicators. You should not be deleting any indicators. But if you are visualizing your formative measurement as causal construct, if the items are highly correlated, you can opt to delete some of the indicators. That is given in this paper by Ken Boland in 2011. So I have a paper in a journal called Information and Management, which I got into the project later after they collected the data. And I was roped in to run the analysis. So while running the analysis, they had a formative measurement with many items, I think about 9 to 11 items. And many of the indicator weights were not significant. So if I report them in the paper, many reviewers will have a problem with that because most of the weights are not significant. They are not actually measuring the construct. So what I did was I started searching and found this paper. So I argued that maybe because this measurement is causal construct, so there are some items which are interchangeable. We drop some item to improve the model. Okay, so you can look at this paper, which is published in MIS Quarterly for a better understanding before you start jumping into this formative measurement. So here in Hare's book in 2014, he actually gave an example of a variable which can be measured reflectively and also formatively. Okay. The variable is called satisfaction. Satisfaction. So on the left-hand side, we have satisfaction. So if you are satisfied with the hotel, you will appreciate the hotel. You will look forward to staying in the hotel and you will recommend the hotel to others. But we can delete any of the item because the arrow is going this way. So the meaning does not change because the arrow is going out. Okay, here we have the same measurement called satisfaction. We have 3 items. The service is good. Personnel is friendly. The rooms are clean. Okay. Here, they are actually forming the variable called satisfaction. You cannot delete any of them because they are measuring different facets of the service. Okay, different facets of the service. So that's the basic difference between a reflective and formative measurement. And again, a variable can be measured reflectively or formatively. You have to decide, okay, whether your measurement is reflective or not. No? And this is how serious is the problem, okay, of misspecification in papers. Okay, prior to 2008, I actually did know about this measurement, which is reflective and formative. when I submitted to a journal called the Enterprise Information Management, I had a variable called service quality, which I measured as reflective. We submitted a paper and one reviewer gave minor revision. Impact factor of the journal at that time was 2.8. One reviewer gave minor correction and second reviewer wanted to reject because he argued that service quality is actually formative. So we actually updated the paper and submitted revision the second round. And the reviewer was still not very happy and he sent us some materials. One of the paper he shared with me was by a guy called Diamantopoulos. When I started reading the paper, I realized maybe we were wrong, but we cannot change the arrow now because when we collected the data, we said it was reflective. But now we are arguing it's formative because of the review. That doesn't make sense. That we call as reverse engineering. So we tried our luck in the third round, and what the reviewer said was, you already have a paper in 2005 by Wixom and Todd, which visualize service quality as formative. So now he's telling us you didn't read the literature carefully. Okay, so we got rejected. So after that, I started reading on this issue called reflective and formative measurement. And what has happened is, this is a paper written by Jarvis in 2003. And on the row here, we have the author's model as reflective or formative. This is what it should be, should be reflective or formative. Okay, so this is what they did, and this is the correct one. So if you see here, type 1 error, which is model as reflective should be formative. And this type 2 error, model as formative should be reflective. Okay, type 1 and type 2 error, total combined, 1/3 of the papers published were wrongly modeled. And which journals are they? They are Journal of Consumer Research, Journal of Marketing, Journal of Marketing Research, and Marketing Science. Okay, Journal of Marketing takes 3 to 5 years to get a paper published. If you publish a paper in Journal of Marketing, you can walk into any university in the world. Okay, that's the kind of level. We call them Parasuraman Malhotra level. Okay, but unfortunately, I've not seen any Malaysian who have published in Journal of Marketing. And these are the top journals. And 1/3 of the papers were wrongly modeled. So gone are the days that you can say because previous researcher used them as reflective, I also model them as reflective. Now reviewers don't buy the idea anymore, just by using citation. Yeah. Any question? Abid? Anybody?
هي أنا أنظر ليان كنا نرسم مع بعض.
لأنه ليان احتمال تنسحب من البرنامج فقلنا شنو مشكلة موجودة.
There's some noise around. Okay. So that is how serious this problem of specification and measurement. Although I'm not very keen to do this, but I've started looking at newer measurement, and there are recent papers that are actually proposing that some of the measurement we have been using as reflective are actually wrongly modeled. So start looking at more recent papers before you start developing your measurement model. Okay. Any question on this reflective formative measurement? Anybody? Any question?
No, Prof. No, Prof.
This is okay. Okay, so that's first part. You have a choice between reflective and formative measurement. Okay, the second choice you have is we have a term called unidimensional and multidimensional measurement. Okay, what is meant by unidimensional is we want to measure a variable called knowledge sharing with 8 items. This is the first way of measuring knowledge sharing. Okay, the second way of measuring knowledge sharing is from Bock et al. In 2005. They have 2 dimensions, implicit and explicit. So we are measuring the variable called knowledge sharing. And the third measurement comes from Jialin Ji, 2009. Knowledge sharing again, we have 4 dimensions. Okay, so here we have knowledge sharing, and also knowledge sharing. So this is what we call as unidimensional. These two are multidimensional. Okay. So here, how many variables we have here? We have one here, right? Okay. Here, how many variables do we have here?
3.
Okay.
No.
How many
2.
variables do we have here?
5, Prof.
How many variables we have here?
5, Prof.
5.
Okay. Incorrect, huh? You have only one variable, huh? You have only one
Four.
variable. All
This is
one variable, huh? See here, this is knowledge sharing, right?
Yeah.
This is also knowledge sharing, huh? But they have 2 dimensions, huh? But variable is still one.
Oh, okay.
Knowledge sharing, right? Here we also have knowledge sharing with 4 dimensions. Huh? So the dimensions are actually measurement of the variable. Huh? Okay.
I
So
read
this,
order.
this is called hierarchical component, right? Or second order. Okay. But the variable is still one. The variable is still one. Huh? Okay. This is something you have to decide. Huh? And in the literature, we have all 3 measurement available. Huh? To measure the same variable called knowledge sharing, you have to decide which one you want to use. I normally will go for the shortest possible instrument. Huh? Shortest possible instrument. Huh? Okay. Okay. When you adopt the measurement, you must also know how to draw them in your software. What happens is some people who have the measurement like this, what they do is they take all the items and force them on this variable, which is not correct. Huh? So if you take all the items and force them into one, you are saying all these items are unidimensional. Many of the items will get deleted. This is one problem I'm seeing a lot with many PhD candidates. They just put all the items as one variable called knowledge sharing. That is not right. That is not right. Okay. You have to model them like this in your software. Yeah. Any question on unidimensional and multidimensional? Okay. Next, we'll go into data collection. Okay. For data collection, we have this issue called common method bias. Okay. Common method bias, common method variance. What is the difference is, okay, common method variance is the higher R square that you get when you collect data from the same respondent. Okay, you collect data from the respondent, and on the right hand side is also answered by the respondent. So what will happen is the R square will be higher than what is supposed to be. That is called common method variance. Okay, common method bias is related to the theorized relationship. Okay, let's say the theorized relationship in the population is 0.2. But because you collected data from the same respondent, you get the beta as 0.6, which is 3 times higher than the actual relationship in the population. That is what we call as common method bias, because the way you collected data, that's why you get that result. Okay, and this is how most of us collect data, correct? How many of you have who collect data which is like this? Your independent variable, the mediator variable, dependent variable, moderator variable, all collected using one questionnaire. Yes or no?
Yes, Prof.
Yes.
All of you, right?
Yes.
Yeah.
All of us come from the same training. Don't worry. I also do that. Okay, but what is happening now is, if you submit, I also realized recently only, I think about maybe 5-6 years ago, when you submit to good journals, one of the first questions they will ask is, since you collected the independent variable and dependent variable from the same person, it will be correlated, right? We call it the consistency motive or consistency bias. So you answer on the right, you also answer on the left. You will have the correlation. So what they are suggesting is, when you have a single source data, you need to address this bias. You need to address this bias. Okay, for data collection, we have data source. We have single source, multi-level. The one we have been using for a long time is number 1, which is like this. We want to study the personality and performance of employees. Personality and performance of employees. So here, the data comes from employee. The data comes from employee. Okay, same source, right? Same source. Huh? And how you collect data? You use questionnaire here. You use questionnaire here. So primary data, primary data. So we have same source, same method. This is what we have been doing for a long time. Huh? Okay, we can also do like this, right? Here we have multiple source of data. Method is the same, primary, primary. Here we use questionnaire about personality answered by the employee. This is answered by the employee. This is answered by their supervisor. Okay, but the unit of analysis is still employees. Is still employees. This also can be done. Okay, but it's more difficult to do. More difficult to do. But you need to know that this can be done. And many reviewers are actually requiring this kind of data collection now. If you want to penetrate good journals. Okay, if you want to penetrate good journals. Okay. The third one is multiple source and different method. No? Okay. Personality is answered by the employee using a questionnaire. The dependent variable is not answered by the employee. You take it from annual evaluation, which is secondary data. So here we have primary data. Here we have secondary data. Here questionnaire, and this is secondary from the database. Okay. So these are the different sources of data. Okay, different sources of data. But unfortunately, all of us are trained with number one, right? Which is this one. You send one questionnaire, everything comes back. Independent variable, dependent variable, moderating variable, mediating variable, control variable, whatever variable you have, right? Okay, that you will get into problem when you submit to higher level journals. Okay, higher level journals. In some instances, you cannot do away with collecting data from the same source. But we also have some remedies. You need to think about how to address that bias. Okay, how to address that bias. Okay, we also have another data collection which is called multi-level. Okay, multi-level. What is the difference is now we are collecting data from organization. We also collect data from individual. Okay, here we have 50 organization, data from 50 organization. Here we have 451 employees. Okay, can we do this analysis in SPSS? Yes, no? Okay, you cannot do that, right? Because the kind of analysis we do, we must have 451 here, 451 here, and 451 here. Okay, but we can still do this with the software called HLM, hierarchical linear modeling, or another software called multi-level windows. Okay, multi-level windows. We have to do some aggregation. So what we will do in normal study is you will bring this down to the individual level. So the employee will rate high performance work system. They will rate the employee well-being. They will also rate job involvement. Then you have same number everywhere. Okay, which is not the correct way of doing things, unfortunately. Okay, but I have never done this kind of modeling yet. Okay, I'm still trying to learn how to analyze them using the software. Yeah. This is different sources of data and levels of data. Any questions? Anybody doing like this?
No, Prof, but we always get from the editors this question that why we are not going for this multi-level analysis.
Yeah. Okay. Now you see, right? Now the reviewers are also raising this issue. So at least you are now aware that these are possible things you can do. Whether you want to do or not is a different story. Because not very easy to do that. Not very easy to do that. So why this becomes an issue is when we measure variable, we have three components. One is called the true score. The second one is called a random error. And the third one is a systematic error. This is the one we are trying to address, this part, the systematic error. Okay. So if you collect data using the same source, you run into a problem called the systematic error. Okay. This is where Potsakov started writing in 1986 about this issue called common method bias, and up to 2012, he's still writing about the same thing. Huh? Okay, so you may want to look at some of these papers which talks about this. Huh? So this is a paper by Doty and Glick where he explains that because you collected data from the same respondent, common method variance results in 26% bias in the observed relationship among construct. Okay, this is what is stated. Huh? But this level of bias still cause for concern, but does not invalidate many research findings. This is what he argued. Huh? Okay, this was a paper we submitted in 2016 to a journal called Total Quality Management and Business Excellence. Huh? And when it came back after the review, these are some of the questions, these are some of the reviews they gave. Huh? One was non-response bias. This you don't have to worry anymore because based on the paper by Hulan et al., this is actually non-issue. Huh? Okay, the second one is he was asking about fit statistics, huh? Whereas in maybe this reviewer was from AMOS. Huh? So he thinks we are also doing AMOS analysis. He's asking us where's the fit statistics. Okay, and the third one is what we call as the common method bias. Okay, so he suggested a test called single factor. I think Abid, Nastaran all did that, right? Abid?
Yes, yes.
Okay. This is
Yes,
also no
Prof.
longer acceptable. Nastaran, huh?
Yeah.
No longer acceptable. Huh? Okay, but in 2016, I still did that huh? Because the reviewer requested. Huh? So those are some of the changes happening with the way you analyze data. Huh? Okay, this issue of common method bias is now being raised by every other reviewer. Huh? So if we are doing single source data, you need to be more prepared. Okay, you need to be more prepared. We also have journals that don't like single source data. This is a journal called Journal of International Management, and the editor is a guy called Mike Kotabe. One of our DBA alumni actually submitted a paper. This is a Q1 journal, Journal of International Management. After 1 year, he got revised and resubmit, 2 revised and resubmit. He was very happy. So he revised and resubmitted. What happened was the editor rejected the paper after reading the paper. And what he wrote was, my careful review leads me to believe that this manuscript does not meet JIM's publication thresholds, as your data probably suffer from common method self-informant bias, because both the dependent variables and the independent variables were responded to by the same respondent. As you may know, this is now considered a serious flaw in management research, if not in marketing research. You need to collect or develop more objective measures of the dependent variables in your study design for external validation, or satisfactorily justify that self-informant bias in the use of subjective measures was minimal or non-existent. As I said, this issue may not be considered serious in marketing journal. So he's telling you, take your paper to a marketing journal. Okay, maybe they will accept. Huh? So this is the kind of reviews you will get for those who have single source data. You need to plan ahead, some remedies. So for this, we will have 2 types of remedies. One is procedural remedy, steps you take before data collection. And we also have steps taken after data collection, which is called the statistical remedy. Okay, the statistical remedy. Yeah? So, yeah, one of the method now being suggested to address this is called the marker variable. Marker variable. What is meant by marker variable is, this is the relationship we want to test between job satisfaction and organizational commitment. So when we run the analysis, we get an R square of 30%. Okay, 30%. So what we are requested to do is, since we collect data about job satisfaction and organizational commitment from the same respondent, we need to address this called common method bias, common method variance. So what we will do is, these are examples of some marker variables. These marker variables are theoretically unrelated to your independent and dependent variables. Okay, these are examples like cognitive rigidity, positive affect and negative affect scale, social desirability, preference for color. Some of them are given in the slides even. You can look at them. So what we will do is now we will point the theoretically unrelated marker variable to the dependent variable. Okay, so originally was 30%. Now it increased to 32%. So the increase is not substantial. What is meant by substantial increment is at least 10%. Okay, why 10% is because if your beta value is 0.3, you square it, you get 9%. So 9% is rounded up to 10%. So any increase of 10% or more indicates strong common method bias. Okay, strong common method bias. Okay, and most of my PhD students now, as a standard operating procedure, they have this marker variable collected before sending out the questionnaire. Many people attend workshop after collecting the data, and then the eyes will blink, blink, blink non-stop. Okay, that's what I'm seeing with many PhD candidates who attend my workshop after collecting data. So these are some of the things you need to plan ahead. Okay, and later I will show you some of the papers you can refer to. I think. Okay, one of the tests I will show you. I will show you the marker variable testing, and also this test called full collinearity. Okay, a full collinearity. What is meant by full collinearity is we will create a dummy variable. Okay, so I'll show you. Okay, so if you run a model like this, how many VIF will you get? How many VIF will you get? Yes. Variance inflation factor. How many variance inflation factors will you get?
5, Prof.
Yeah.
5?
Okay. Nastaran is a strong smart PLS person.
No, Prof.
Huh? You use a lot of smart PLS, right?
Yes.
Okay. Abid, how many you have?
5.
5, huh? Okay. Not correct, Abid. Huh? Only 2. Huh?
4, Prof.
Only 2. Only two. Huh? Okay. The one you're supposed to get VIF is here, 1 and 2. Okay, 1 to 1, there's no VIF.
Oh, okay.
Okay,
Yes,
but
Prof.
in the software called Smart PLS, they will give you a value of 1, correct?
Yeah.
Okay, but that's not a test. Huh? That's because by default they put a 1. Huh? When you have one dependent variable, there's no test of VIF. So when you have more than one independent variable, then only the VIF comes in. Huh? So if you run a model like this, if you see the result like this, these two variables, team success in terms of investment and sales, they are highly correlated. Huh? But if you run your variance inflation factor, they will only give you 2 values. Okay, because you have only these 2, right? Number 1 here and number 2. So they will give you 2 values, and you will conclude there's no problem of multicollinearity. Huh? But you have here, right? Very high correlation. This is actually multicollinearity. Huh? So what they suggest is we can run a model like this. Huh? We have all the variables, independent and dependent variables, regress against a random dummy variable. Okay, this we can do quickly in Excel or SPSS. Okay, and if you run this analysis, you will get VIF including for the dependent variable, And one of the mistake I'm seeing with many papers and thesis is they run the analysis in Smart PLS. They will report the VIF from Smart PLS and with the header full collinearity. That's incorrect. Huh? The test you get in your Smart PLS is called vertical collinearity, only for the independent variables. Huh? Only for the independent variables. So this is something you can do. And when you run this estimate with 5 variables, they will give you all the VIF. So if your VIF is more than 5, you see these 2 variables? They are more than 5. Huh? That indicates multicollinearity. Huh? So if we have literature to suggest these two can be combined, then we can combine them. Okay, we can combine them. No? So this is what happens. So they combine the two variables to become team success. And then when you run the full collinearity test again, you don't have any value greater than 5. So this can be done quickly to counter the argument of common method bias. Okay, common method bias. This is available directly in the software called WattPLS, but in SmartPLS we have to do additional analysis. Okay, so when we do the hands-on, I will show you how this is done. Okay, yeah. Any questions? Yeah. Anybody is using marker variable or full collinearity testing at the moment?
Not at the moment.
Yeah.
Not at the moment.
No. Okay. Okay. Next, we will look into how we determine sample size. Most of you use this. We can use sample size using tables like this. So when we calculate sample size, these are some of the tables available, like Green et al. And all. So one of the things you need to do is you need to determine the biggest regression you have in your model. The biggest regression you have in your model, which will give you the number of predictors. So based on the number of predictors you have, we can use a software called GPower to do the calculation. Okay, so if you have 3 independent variables, okay, we have to first decide what is the effect size of the relationships. If the effect size is small, then you need 547. If the effect size is medium, you need 76. And if the effect size is large, you need only 35. Okay. This is if you have information about the effect sizes from meta-analysis paper. If you don't have any information, we can stick to the medium effect size here. And for a model with 3 independent variables, 76 sample is enough to get a power of 0.8. Okay, to get a power of 0.8. So anything greater than 76 is okay. Anything less than 76 is no good. Okay, is no good. Yeah, that's how you can decide on the sample size. So I will show you another. You can also use this calculator by Koch and Hadaya. This is available in WattPLS. But Koch and Hadaya, what they suggest is if you have any sample size from 145 to 160, 145 to 160, they should be enough for most of the models that we want to test. So that's the number they are suggesting as a good number for any research. Okay, anything greater than that number is good. Anything smaller than that number is no good. Yeah. Any question? So I will show you how. Okay. Yeah. Any question on the sample size? So I will show you this. Okay. Let's see how whether you know how to decide on the numbers.
Is it going to be done by GPower?
The calculation will be done by GPower, but you have to decide some numbers. So I'm going to show you which. Okay, so you will see whether you understand. Okay, so I will share this. Okay, so one of the things we need to do in GPower is we have to decide on the number of predictors in the model. Okay, the biggest number, right? So if you have a model like this, how many will be your predictor?
3.
Yes, how many will be your predictor?
Highest 3 indicator towards employee engagement.
3 predictors, right? Okay, from here to here, 1, 2, and 3, right? Okay. 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 When you have this model, how many will be your predictor?
4.
4 predictor.
Yeah, Abid, you forgotten already, huh? You will have 7, huh?
Oh, total.
Yeah, biggest predictor, right?
Yeah, total is 7.
Okay. Why 7 is because of this, huh? You have interaction.
Yeah.
Okay, you have interaction. 3 independent, 1 moderator, and 3 interaction. That is why it becomes 7. So for a model like this, when you do calculation using the software called GPower, you have to put 7. Okay, you have to put 7. Okay.
If there is any moderation.
If you have moderation, the first one, see here direct. So here we have 3 here, right? 3 independent, 1 dependent, and 1 independent, 1 dependent, right? So the biggest number is here. Okay, biggest number is here. But when you draw the model like this, we call this the conceptual model. You do in chapter 2. But when you test, we call them the statistical model. Okay, the statistical model will look like this. You have 3 arrows pointed from the independent to the dependent. You have the moderator also pointed to the dependent, and you have 3 interaction between the independent and the moderator. Okay, so that's where the 7 comes in. Okay, 7. Okay, if you have a model like this, how many will be your predictor?
Four, Prof.
4, correct. 4. You have the direct. Okay, some people do the direct arrows also. So if you have this, the first model, we didn't have the direct arrow. The second one, we had the direct arrows. So now it becomes 4. Okay, it becomes 4. And okay, here we have a moderator. We also have control variables. So if we have a model like this, how many will be the predictor?
Okay. I think Prof 3. Three.
Okay. So you have problems with the statistical model. This is how you will test.
Yes.
So how many arrows here?
Oh, 5. Age
5,
and gender.
Yeah.
Yes.
That's a control variable. That's a control variable. They are also counted when you run your
Yes.
analysis. So that's how you have to count. Here we have all direct relationship. Okay. Let's say we have a model like this. How many will be your prediction?
Predictors.
Because when you calculate sample size, you will use the largest regression you have in your model. The largest regression you have in your model, right?
4.
4, Prof.
4. Highest is 4. To comp and like.
Okay, look carefully.
Prof, you should calculate items as well.
Okay. If the items are formative, they also considered as
If
regression.
items is quality.
Right.
Yes.
They also considered as regression.
Yes.
So how many?
8.
So 1, 2, 3, 4, 5, 6, 7, 8.
Here, right?
Yes, quality.
So this will be the biggest. This will be this. You have 8, right?
8.
Here you have 5. You have 5. You have 3. Then here you have 4. You have 4 here and 3 here. So the biggest is here, right?
Yeah.
So you will use 8. Okay.
Yeah.
Any questions? So I will show you how you can run them with the software. Do you have G-Power installed?
I
Alright.
don't.
Okay. In the folder I gave you, huh?
Okay.
Can you go to the folder I gave you? Huh? Okay. This is the software. The folder I gave you is the, where is that? Okay. This one. I think February, huh? Yeah,
February.
this is the folders I gave you, right?
Yes.
Okay. You will go to folder number 5, huh? G-Power.
Yes.
Okay, here we have two versions. One is for those who have Macintosh. If you have Macintosh, then use the Macintosh to install. For those who use Windows, you just click 3.1.7 and then click the setup and then follow through. Then I will show you how the calculation can be done. Okay, what they have. Okay, so once you install, you have this G-Power 3.1.
Okay.
Okay, the rest, anybody having problem with the software? Okay, so this is the software that is now very popularly used for calculating minimum sample size. What the software will tell you is the minimum sample size needed, not the best sample size. Okay, not the best sample size. Sample size should be bigger. Bigger your sample size, it is more representative. Okay, let's say we want to calculate a sample size for this model, which has 8 predictors, right? 8 predictors. So to calculate analysis, here we have the test family. So for regression, the test family will be the F-test. Okay, will be the F-test. Once you change the F-test, on the right here also they will change. Here we have a lot of MANOVA, ANOVA, and so on. The one we want to test is this. Linear multiple regression, fixed model, R-square deviation from 0. That is what we are going to do, okay, for sample size, since we are running regression. So once you click here, we have 2 types of calculation. One is a priori, which is done before data collection, and post hoc, which is done after data collection. Post hoc is not recommended, so we will stick to a priori. So the first number you will look at here is called the effect size. Okay, the effect size is given as 3. 0.02 is small, 0.15 is medium, and 0.35 is large. If you know your relationship parameters, how strong they are, then you can change them. If not, you stick to 0.15, which is the medium effect. Okay, which is the medium effect suggested in most statistics books. Okay. The second number you have is your alpha. You can change it to 1% or 5%. 5% is 95% confidence. Sample size will be smaller. If you have 99% confidence, sample size will be larger. Okay, so that's where the numbers come in. So this is actually your confidence. 5% and 1%. Okay, the power is where you need to change. Okay, for those who are doing social science management research, you don't need a power of 0.95. Okay, that is done in the sciences. We need only a power of 0.8. Okay, 0.8. Okay, that's the third number. Okay, that you have to change. And the last one is depending on your model. Okay, what is the biggest predictor you have? So here we have 8, so we can put in an 8, and the software will give you to test a model like this with 80% power. You need a sample size of 109. Okay, 109. Any questions?
No.
Anybody? Anybody?
At
Okay.
least 109 sample, right, Prof?
Yeah, minimum. Anything less than that, the software will still run, but you don't have enough power. Okay, so that's why now many reviewers are actually asking whether you actually ran some power analysis to decide whether your analysis has enough power.
Prof, in that case, do we need to, show them this figure?
No, you can write
Or
in the text.
the appendix?
No. If you are writing thesis, normally they show this. But if you are writing a paper, you can say we ran a G power analysis with the effect size 0.15, alpha 0.05, power of 0.8, and the number of predictors, so many.
So just mentioning these things. But for the PhD thesis, we must ask the students to incorporate.
Normally they will screenshot and put in the appendix.
Okay.
Because many examiners don't know.
Yeah.
Okay, and then you get into a debate, why you didn't use Craigie and Morgan, right? Craigie and Morgan is out, 400 sample size, right? That has been cited without actually understanding that when we do sampling, one of the important thing is how representative is your sample. How representative is your sample. It actually relates to judgment, how you select the sample, not about the numbers. You may have 400, but you collect from only one university. That's not representative. Okay, so the way you collect is important than the numbers.
Right.
Okay, so this is sample size. Okay, many people have started using this to show minimum sample size. Not the best lah. Okay, so I will post this. Yeah. So that's sample size calculation. Okay, sample size calculation. Yeah. Any questions related to what we have discussed so far before we move on? The next one will be this pre-testing and pilot testing.
Prof, one thing regarding this sample size, sometimes respondents or manager, it's difficult to collect data from them. Maybe they don't have time. So in this case, we should still maybe sometime minimum number also.
Yes. Minimum is needed. Or else your analysis, we don't know whether they are not significant because you don't have enough power, Nastara.
Okay.
So if we already have the minimum number, then you can say if they are not significant, they are actually not significant.
Okay.
That is the reason why we are doing that power analysis. Okay.
And one more thing, Prof, regarding the model fit. Just now you said that about the PLS, no need to report the model fit.
No.
But I got a comment from reviewer in journal asking me to add the model fit.
Okay, the problem with the PLS model fit is they were developed, the fit values were developed using common factor analysis. But you are actually not doing common factor, right? You are doing composite, no? And most of the time, SRMR may be okay, but NFI will not be good.
SRM, yeah, they asked me to report the SRM. Yeah.
SRMR you can report, most of the time it's okay, but not the NFI.
Okay, thank you.
Non-fit index, right? Okay.
Yeah.
Okay. Next, for pre-testing, one of the stages you do is called pre-testing. How many sample do you do for pre-testing?
Pre-testing.
Yeah.
It depends on the,
A bit.
yeah, depends on, I think, the respondents, because
Yeah.
we need to get feedback from researchers, experts, and also respondents.
Yeah.
8 usually, sometimes.
Okay. I think many people are not very clear about this. Maybe the training, most of the time, that's why they say 30 is enough for a pilot test. For a pre-test, pilot test is also part of pre-test. So for pre-testing, we have these 6 different things we can do. Number one is called respondent debriefing. This is after you develop your questionnaire. At the end, you have a closed, open-ended page that you ask them to write their comments. Okay, at the end of the survey. So you want the feedback from them to see whether they have problem understanding some of the terms or wording in the questionnaire. Okay, this can be done, number one. And number two is the one I do a lot with my students. This is called cognitive interviews. This is a smaller number. Okay, it doesn't have to be 5 to 15 anyway. Most of the time 3 to 5. 3 to 5 respondents. But you sit with the respondent, go through the questionnaire. You want to see whether the respondents are actually respondents actually understand the question or they are rewording the question. That is where this cognitive interviewing come in. And this is the one many people think as pre-test. Many people call this as a pre-test. This is actually not pre-test. This is called cognitive interviewing. Yeah, the third one is expert evaluation. Many people do this, but they also don't have an idea what they're actually looking for. Here we have 2 types of experts. One is the topic expert. The other one is the method expert.
Yeah. I have this overload form.
Yeah, Abid, your microphone is on, I think. Okay. Here we have 2 types of expert. One is called topic expert. The other one is the methodology expert. You have to use at least one of them. One topic expert, one methodology expert. Because the methodology expert will look at the instruction, the scaling, and so on. Whereas the topic expert will only look at the questions. Okay. And what I see is most people use only the topic expert. They don't use the methodology expert. You may get into trouble with that. Okay. So those are the 2 people if you still want to do. Okay. Number 4, you can do focus group. This is where you can run a focus group with about 6 to 10 people and discuss whether they have problem with certain questions. For example, I did a survey on internet addiction. And one of the components in internet addiction is called phonography. And when I asked my respondent in a focus group, one of these, my student was telling me, if you ask me, sir, I will say no. But actually, yes, everything yes. Because phonography in Malaysia is actually illegal. So even if you ask, they will answer no. So we can actually take out that component from the measurement because of the contextual issue. That you have to do with focus group. You cannot say that I want to take this component out. So we run this focus group for that purpose. We can also do experiments, different design of the instrument. Some with the demographics first and then the survey question later. Some with the survey question and then demographic later, and see whether the answers are better which version of the questionnaire. That's called experiment. And the last one is the one we do pilot test with 50 respondents. Here, this website called Qualtrics suggests at least a 50 respondent for the pilot test. Okay, for the pilot test. Yeah. Those are some of the things you do traditionally. Okay. Other ways of doing things is this called card sorting. Okay. This is the paper you can refer to. One of my PhD students from Bangladesh. This is the one and only one who did this. He attended my workshop, and then when he collected data, he did this card sorting online using Google Form. He has some IT background knowledge. So he actually set up this Google Form where you give them all the items, which is like this. Okay. And then you have the constructs. These are the constructs. So the respondent will take the item and sort into the construct. And then you will calculate how many % correctly classified. That will tell you whether the respondent understands that the question is measuring certain construct. This can be done. But this is quite messy because you can run first round and then you get 80%, then you run second round 85%. You may want to modify until you get about 85%, 90%. Then only you can run the actual study. So this is a good paper that you can refer to for the process of doing this card sorting. Here you don't have to have actual respondents also. They can be some people in doing research related to the topic, or people who are related to the research. This study was on playing games. So they also look at people who develop games as one of the card sorting experts. Okay, so you can look at that. Okay, the other one you can do is based on this paper by Hardy and Ford. What they suggest is you give them the item and ask them to explain what they understand with the item. Okay, here we have two respondents who answered 4 to the same question called satisfaction with pay. Number 1 answered 4, number 2 also answered 4. But when you ask them to explain, number 1 respondent said, the pay is enough for the work I do, okay, which is actually equity. But the second respondent actually said this, the pay is enough for me not to leave. The second respondent is actually not answering the question. He's actually relating the variable to another variable maybe in your model called turnover. This is why you will run into a problem called multicollinearity or discriminant analysis during your analysis because you didn't check for this. Okay. Here what is happening is the respondent is actually extending the question, which is not supposed to be. They're supposed to only rate based on pay, not to relate pay to another variable. Okay, this can only be done if you do this. Okay, if you do this. Okay, nobody wants to do this because this is quite messy, and if your questionnaire is long, nobody will answer explanation for many questions, right? But you can also do parcel. 10 questions, 1 respondent answer, another 10 questions, another respondent answer. That also is possible. Okay, so those are some of the ways you can do your pre-test pilot test. Okay, yeah. Okay, for non-response, I already mentioned we don't need to cater to non-response. Common method bias, when we do the analysis, I will show you how it's done. Okay, missing value imputation. This is what do you do when you have missing value in your data? Okay, so these are testing procedures, so we will not look at it. So for common method bias, you can look at here. I've actually summarized from the literature. These are some of the things you can do. One of the variable that you can use is this called social desirability measure. This is used a lot in psychology. There are some shorter version and the longer version. This is called a marker variable. Harman single factor test, this is the one everybody is using, and they've cited this paper, but actually recent research saying that the paper did not say that, but everybody is citing this paper for Harman single factor test. Okay, this is where you run them like this. Point all variable to 1 factor and see whether you get some percentage which is more than 50%. This can also be done by EFA. Okay, like this, right? So you run all the variables and then you look at the first factor. If the first factor is less than 50%, you don't have a problem called common method bias, common method variance. Okay. Okay. The second method is called partial correlation method. This is when you run your factor analysis, save the first principal component, use that variable as control variables on the dependent variables. Okay, on the dependent variables. Okay, like this. So you run your factor analysis. You run your analysis, you get 50%, and then you run the analysis with your first in your factor analysis, the first component. You save the score and point it to your dependent variable. So here 50%. Here you get 52%. The R-square change is less than 10%. You don't have a problem called common method bias, common method variance. That's one way of doing things called partial correlation method. No? Okay, Lindell and Whitney test is the one we will do later. This is where you have a theoretically unrelated marker variable we collect. And then when we run the correlation, we see whether the correlation is less than 0.3, less than 0.3. Okay, that's the idea I gave you just now. 0.3 squared, you get 10% R square. So that's a Lindell and Whitney. We can also use correlation metrics. This is suggested by Baghosi et al. In 1991, but not many people use this anymore. Okay, and this is a more recent one by Chin in 2013. Also measured latent marker variable, but instead of pointing at the dependent variable, he asked to point at all variables in the model. This is slightly more difficult to do analysis-wise. So those are some of the possible things you can do. So I will some of the references. Okay. For missing value, anybody doing missing value replacement techniques, or are you just ignoring that? Yeah. Anybody doing missing value replacement? Yes. No. Abid? Nastaran?
Yes, Prof. If the data we collected, there is some missing value, we need to use the
what do
missing value.
use?
EM I use.
EM, okay.
Yes.
Yeah. Okay. So the traditional method of replacement is the first one, where you don't replace any values. That's actually not recommended. Do I have the example? No. Okay. The second one is called the midpoint of the scale. So if your scale is 1 to 5, your midpoint is 3. You replace all your missing value with 3. That's called midpoint of the scale. Okay. Number 3 is random number. So if your scale is 1 to 5, you write 5 numbers, put into a box, pull out one number and see what you get. So that is random number. Mean value of the other respondent is, we look at that item, take the average of all the valid cases, replace that mean value for the missing cases. The last one is, if you have 3 items for measuring a particular construct, they answer only 2 questions. You take the average of the 2 questions to become answer for the missing response. So those are some of the things done traditionally, but this is no longer acceptable. Okay. So the current methods are full information and expectation maximization. I do a lot of expectation maximization. Multiple imputation is slightly more difficult to understand. Okay. Full information maximum likelihood is available in a software called AMOS. Okay. For those who are using SPSS, we have this technique available called missing value replacement. And for missing value replacement, we will do a test called Little's MCAR test for whether the data is missing at random, missing completely at random, missing at random, or missing not at random. So we have MCAR, MA, and MNA, which is the term used in the literature. So we can use this missing value analysis and do the replacement. And most of the time, I will also use expectation maximization. This is the technique that I also use. Okay, so those are for missing value. Yeah. Any question? Any questions? Abid, Nastaran? Nobody?
I have no question, Prof.
Okay. Okay, we will stop here for lunch, and then come back at 2 p.m. Your time, right? Nasara?
Yeah, 2 p.m. Yes, another 1 hour and a half. Now it's 12:30.
Yeah.
Okay.
Okay.
Doctor, thank you so much for the interesting workshop. Do we have to download the SPSS?
I've given you in the folder. Huh?
Yeah. I just saw it, but do we have to download it?
Yeah. We will do some analysis using SPSS also.
Okay. Cheers. Thank you.
But you have to do a crack later. You know how to-
Yeah. I'm using my personal laptop, so I can do it.
Okay.
Thank you so much. Cheers. Thank you.
Thank you.
Prof,
So-
thank you for the workshop. Just I would like to know about the folder. I didn't receive it.
Abid, did they share?
But yeah, okay, maybe we can send again. Dr. Salim yesterday sent us the folder. It's a Google Drive.
Yeah. Let me see.
Oh.
Yesterday we received the email, I think.
There's a link that you can download from Google.
I think here I can share here, Prof, in text box, the link.
Yeah.
I think this is the link, Google Drive, so you can download all the files.
Quite a large file, so it will take some time
Yes.
to download.
I think 4 gig, more than 4 gig.
More than 4 gig. So you have to download that.
Yes.
Yeah, I have downloaded it, but I couldn't open it. It says it's damaged or something.
No, you need a software called WinRAR.
WinRAR.
To extract, yeah.
This is the file.
What's the name of the software again, please?
WinRAR.
WinRAR is type here.
Oh yeah, or WinZip. It's working with me.
Yeah.
But you actually can open with WinZip. If you have WinZip, it will work.
Yes, I think.
You just right click
Doctor,
and open
Professor, I envy you. You managed to meet Herr Sardast, Ringler, all these scholars.
Yeah. I'm lucky in
You
that
are
sense.
so lucky. You are so lucky, and we are so lucky to learn from you. I've been using Amos for the past 10 years, but I know how to use it, but I never went into details to learn the techniques, what's behind the numbers that we usually get out of the software. But today you made it clear for us. Thank you so much.
Okay. So for those who have WinZip, you can right click and then open with. I think it will work.
Yes, open with.
Open with, then you put WinZip, they will still open. If you don't have WinZip and WinRAR, then it won't open.
Yeah.
Okay. So we will come back at 2 p.m.
Okay.
Okay. Thank you.
Thank you.
Thank you.
This morning, before we move to the next step, which is model estimation, which will be, okay. So I already started recording, right? Okay.
Yeah,
so,
you talked about hierarchical component modeling.
Yeah.
Is it
tomorrow.
Is it similar to hierarchical linear modeling or
no? Hierarchical linear modeling is different. This hierarchical component modeling is the common term used in the literature is second order.
Okay. And the linear modeling is
hierarchical linear modeling is
how does it differ from SIM?
That one we have different levels. Like just now I showed you, you have organization, only 50 organization, but individual you have 400. So far we don't do that kind of analysis, right? But we can still do that kind of analysis. This is done a lot in HROB studies.
I see.
But The training we got was everything we do at the same level, correct?
Okay.
Okay, so we have even the organizational level wherever we bring it down to the individual level. So the employees will answer everything. That's what we have been doing for a long time. But this is being questioned in good journals. If you submit a good journal.
So SIM can only test one level of analysis.
No, you can, but you have to do some procedure called aggregation. At the moment, Smart PLS cannot do that.
Okay. Okay. That's
But
fine.
okay.
Thank you very much.
Look at PLS path modeling. So for PLS path modeling, this is how you will draw the model. And then when we test the model, we will follow the two-step approach, which is the measurement model and the structural model, suggested by Anderson and Gurvey. We have been doing this also in SPSS. The measurement model in SPSS, we do reliability and factor analysis. When we move to structural model, we are actually doing regression analysis. So we are actually not doing something new, but they have now repackaged the analysis into two components, measurement model and structural model. Okay, one of the differences you will see from Smart PLS and AMOS is when we do measurement model in AMOS, you will put all variables correlated and then you run the measurement model. When you do structural model, then only you have your one-way arrows. But here in Smart PLS, this is one of the requirements. You must have two variables connected. Okay, that means you must have this variable and this variable connected. This is the first requirement. And the second requirement is each circle must have at least one item. If you have item here, no item here, also the color will be red. Okay, the color will be red. That's a requirement now for Smart PLS, but not in Watt PLS. Watt PLS, you can run the model without any one-way arrow for measurement model. But Smart PLS, you cannot do that. This is the first requirement. The second issue with Smart PLS is your endogenous construct cannot be a categorical variable. Your exogenous can be a categorical, but the endogenous, like regression, you must have a continuous variable, multiple item at least. Okay, multiple item at least. That's a requirement. So how the software understands your model is they will divide the model into two parts. The first part is from the construct to the item. We call this the measurement model. So this is called the outer model. Same here, both sides are outer model. And from construct to construct, we call them the inner model. Okay, the inner model. So both for both the inner and the outer model, you need theory. Okay, from the construct to the item, we call them measurement theory. Is the measurement reflective or formative? That's the theory. From construct to construct, we have also a theory called structural theory. Structural theory is where you have theory of reason action, theory of planned behavior, technology acceptance model. Those are what we call as structural theory that links variable to variable. Okay, variable to variable. So both theories are needed when you do structural equation modeling. So that's how the model is created in Smart PLS. Okay. So in Smart PLS, they will have the software with only three icons. One icon is the circle, which is this. This is to draw the latent variable. This is to connect the latent variable. And this is to come out of the latent variable modeling. That's called the selection mode. No? Only three buttons. Unlike your AMOS, where you have photostat machine, you have LORRI, you have the magic wand and so on. Here we don't have. We have only three buttons, but you can do most of the things you want with the three buttons. So this is the Smart PLS. So the Smart PLS2 will look like this. The Smart PLS2 is still free. They will still provide you a license every 3 months if you still register with them. But Smart PLS2 has only these 4 analysis, which is PLS algorithm, Phimics PLS, bootstrapping, and blindfolding. Okay. Mediation can be done directly in PLS2, but no, moderation can be done directly in Smart PLS2. But if you want to do mediation, you have to do manual calculation for mediation in Smart PLS2. So for moderation, mediation, you still can do, but for mediation, you have some problems of calculation. That's all we can do. Direct relationship, moderation, and mediation. That's Smart PLS2. Okay, Smart PLS3, they changed the layout. Previously, we had 3 windows, which is project, outline, and indicators. The Smart PLS3, now they have reduced the windows to Project Explorer and Indicator. Okay, Project Explorer and Indicator. Okay, the Project Explorer will list all the projects you have in your software. The names here, these are actually called projects. These are projects. So for each project, you must have at least 2 files. One is the drawing, the other one is the data file. Okay, that is the minimum requirement. You can have multiple data files. You can pick which data file to analyze. Later, you can do that. And your indicators will appear at the bottom here, okay, with the name, and you can just drag and drop. That's how the software understands the model. So here you can see that in the Project Explorer, we have a P1. Okay, the P1 with the drawing, this is the drawing. Okay, and the one with the cylinder is actually your data file. Okay, your data file. So this is where we will draw. We call them the canvas. So from here, we can just drag and drop. So if the arrow is going in, we call them formative measurement. If the arrow is going out, we call them reflective measurement. That's how the software understands. For unidimensional measurement, but for multidimensional measurement, that's a bit more tricky. Tomorrow we will discuss about the multidimensional measurement. We can still do that, but you have to be more careful when you are doing hierarchical component modeling. Okay. So the Smart PLS3, there's a slight difference between the Smart PLS 3.3.2 and 3.3.3. Okay, 3.3.2, if you see the items are not dark. Here the 3.3.3, what they did was they have now made all the lines dark, which is much more clearer compared to the 3.3.2. Okay, so I still think this is quite sharp. Now the writings are quite sharp. The diagrams are quite sharp. Okay, so in the software, if you see the listed, these are some of the analysis you can do. The one we will use a lot is PLS algorithm and bootstrapping. Okay, previously you had another consistent PLSC is now moved to the bottom. So we have this PLS algorithm and bootstrapping, which we will use most of the time. So for most researchers, the analysis we do is called a traditional PLS, which is PLS algorithm, followed by the bootstrapping. Okay, that's what we will do. Okay, for those who want to do confirmatory, you will move to the button at the bottom here, which is called the consistent PLS algorithm. Okay, consistent PLS algorithm. They're actually trying to mimic the software called AMOS. Okay, which to me, if you want to do confirmatory, you might as well stick with the software called AMOS, because AMOS has more options and more features compared to Smart PLS. Okay, this procedure called blindfolding is still being used now. You will run this procedure to get a value called the big Q square. The big Q square, which is also termed as predictive relevance. Okay, but now this is going to be replaced with another analysis called PLS predict. PLS predict, you can do hold out sample. So I will also show you both of them. Okay, this analysis called confirmatory tetra analysis, they have added to the software to analyze if the measurement is reflective or formative. But the developers also caution this is actually after the fact or data driven. Sometimes you collect a data which is formative, the software will tell you they are reflective, and you collect data which is reflective, and the software tells you is formative. So instead of following the software, you have to decide based on argument and justification, not about the numbers, huh? Okay. This analysis called important performance map analysis is useful for writing the discussion, it will tell you which variables are important in terms of total effect, and which variables are doing well and which variables are not doing well. So that is what we call as important performance map analysis. Okay. For moderation, we have two types of moderation. One is called observed heterogeneity, and the second one is called unobserved heterogeneity. Okay, for observed heterogeneity, we will run the moderation, which is the one already available, which is called orthogonalization or two-stage approach. But for unobserved heterogeneity, what is unobserved heterogeneity is when you develop a model, you don't have any moderation. But when you run the analysis, you suspect there might be some moderators. And what you want to do now is, after collecting the data, you want to identify whether your data has segments. Okay, segments means different groups in your data. For example, your group can be those with high power distance, low power distance, or high involvement, low involvement, or male, female. They have different relationship. That is the software that we will use is this. Phimics segmentation, prediction-oriented segmentation. These two will give you the number of possible segments in your data. They will not tell you what are those segments. So the first part, they will give you some values that you can decide whether 2 segment, 3 segment, 4 segment, or 5 segment works with your data. The second part will be more subjective, where you go and try to identify what variable you have already collected can be used to segment the data. Once you do that segmentation, you will move to multi-group analysis to find out whether the segmentation is actually working. Okay, that's the subjective part in the second part. No? So this multi-group analysis is also moderation. When you want to analyze moderation for the whole model. Okay, the one we normally do is you have moderation only on one arrow. That can be done with orthogonalization method. But if you say your moderator moderates here, this arrow, this arrow, this arrow, this arrow, and this arrow, all the arrows are moderated, then you will move to analysis called multi-group analysis. This is one of the most difficult analysis available in AMOS and PLS. Okay, before you start doing this multi-group analysis, one of the requirements is to pass a test called permutation. Okay, permutation is actually called an analysis called invariance analysis. Okay, invariance analysis. So they have 6 levels of invariance. Most people don't go up to 6 levels. The one many researchers do is 2 second level, first level and the second level. The first one is configural invariance. Second one is called metric invariance. Third one is scalar invariance. Nobody goes to scalar invariance because we seldom do mean comparison. So most researchers will stop at metric invariance. And for metric invariance, you don't need a full invariance. You only need partial invariance. So the book by Hare has a discussion about full metric invariance and partial metric invariance, if you want to read up on this issue called invariance. Okay, and the last button, which is the consistent PLS algorithm, they give you the PLS which is consistent, and also multi-group analysis, which is also using PLS consistent. Okay, if you want to explore, but I have not seen any paper so far using PLS consistent PLS algorithm and consistent PLS multi-group analysis, other than the papers by Hensela and Dijkstra. Okay, I've written a simple paper using consistent PLS, which I will show you later. The only reason I did that was every time I do a workshop, many participants want to see a sample. So that's the reason I wrote the paper. I think Abid was one of the co-authors of the paper. It was only a sample for those who wants to do consistent BLS. So that's what I did. Okay, yeah. So after you do your PLS path model estimation, we will have two steps called the measurement model and the structural model. So the measurement model, when we do the multiple item, I will talk about the assessment. And for structural model, we will do a path analysis to see the difference between a model without items and another model which has multiple items. Okay. So before we start moving to the hands-on, so I will show you all the materials so you know where to get the materials from once I start the hands-on. So on the desktop, okay, this is the files I shared with most of you. If you don't have, it's actually posted on the chat box, the Google Drive link, and the slides I've already shared also. So you can download from the Google Drive link. You will get all these files. Okay, the most important, the number one is what we call as the data set. The data set I prepared into one is SPSS and also comma separated values, which we will use for Smart PLS. For Smart PLS, data must be converted into comma separated values. Okay, before we can read them into Smart PLS. So the data set, if you see, there are, just in case some of you don't have SPSS, I've actually converted this usage here. So they're actually the same, usage and usage here, right? Okay. We can actually open in SPSS and then file save as. Okay, that's the first thing. Those are data files. The second one, you have the exercises that we will do and also a sample write-up. You can look at how I normally write up. This is one of the latest ones. You can see a lot of things which are updated. Okay, sample, later I will refer to it. Okay, number 3 is the Excel templates. These are the templates we will use when we start doing moderation analysis. So we have two templates, one for categorical moderator, gender, marital status, those kind of variable, we use number 1. If we have multiple item scale, you will use the moderator, which is continuous. Okay, although the software gives you a simple slope analysis, the drawing is not very sharp. Okay, the drawing is not very sharp, so I prefer to use the Excel template to redraw. So I will show you that when we do moderation. Okay, this is the most important folder in the directory. You have here, you have about 400 papers. Okay, 402 papers, 402 papers, because my number starts from a 0. Okay, so actually 401 plus 0 lah. So 402 papers up is already updated up to 2021. Okay, and here you have all the papers I've cited in the slides and also some of the papers which is useful for many kinds of analysis. Okay, so as we go along, I will also refer to them. You can look at the papers directly from this folder. So if you don't have so much time to read everything, I think there's a particular author I would recommend called Aguinis. Okay, this guy. Okay, Aguinis. Just type the name Aguinis on this box here. They will list you all the papers written by Aguinis. This is a researcher who does research on strategic management and human resource behavior. Okay, organizational behavior. He writes really good papers on methods. So to understand better methods and some of the things we are doing wrongly, you can look at his papers. He has written papers on control variables, moderator variable, mediator variable, hacking, best practices in data collection, reproducibility crisis, non-normal data. Most of the things you need to understand in research is already written in paper form by Aguinis. And he also updates his papers on his website. Just type this name. So Herman Aguinis. His full name is Herman Aguinis. So that's a person you should follow. Look at his papers. Really, really good papers. So those are some of the references. Okay. Then I have also given.
Thank you very much, Prof. You're sharing so many things with us. It's really amazing. So many articles you are sharing. Thank you so much.
You don't have to look for them. They actually already compiled for you. Most of them, I think up to yesterday night, I was compiling. So you already have most of them. Okay, G-Power we already installed. I also have shared this folder, which is some of the papers I've written. Later we will refer to them. Papers on EMOS, papers on regression, PLS articles, which the number 1 folder is the older papers. Number 2 folder is the 2019-2020 papers. So you can look at them, some of the changes in reporting and so on. So regression, you can look at regression folder. EMOS articles is also here. You can look at how EMOS articles can be presented. And the editorials I was talking about called Journal of Applied Structural Equation Modeling. We have written these 4 editorials, which are very useful for many researchers because it gives you all the citation you need for different kinds of cutoff values. Okay, these 4 papers. And recently we wrote a paper in Asian Journal of Business Research on multi-group analysis. This is actually a step-by-step procedure of doing multi-group analysis using Smart PLS 3.3.2. Okay, 3.3.2. So if you want to do multi-group analysis, you can refer to that paper. Okay, so those are papers you have. Okay, for ebooks, you have all these ebooks you need. Research method, we have the paper, a book by Uma Sekaran 2019, which is the 8th edition. This is the best book available for research method. No book comes close to that. So this is the book you should read. Really, really good book on grounding on research method. Okay, Uma Sekaran, one of my favorites from the 1990s. I've been reading her first edition up to the 8th edition now. This is the latest one. Okay, for SPSS, you can look at the book by Andy Field, which is the 5th edition. This is quite good. If you want to know how to click and all, we have Mallory SPSS 26, which you can look at. For PLS, we have Hare's book 2014 and 2017. For process macro, you have Hayes book 2018, which you can use. Okay, and SPSS also you have Palan, right? For EMOS, we have the book by Klein and also Barbara Byrne. Barbara Byrne is considered like a Bible for EMOS. Okay, and this is the latest 2 books by Hare. Hare et al. Multivariate data analysis and business research by Hare in 2020. Okay, so those are ebooks for data analysis and research method. I've also shared some books which is available given by Springer for case study, mixed method, and so on. You can look at them when you have the time. Okay, yeah. So that's for ebooks. And thesis, you have some thesis from most part of the world, and I would recommend you to look at 0A, 1, 2, 3, and 4. What's the difference is 0A is Abid's supervisor, former supervisor, who was also my student many years ago. She's now the dean for the school. She did a PhD in Australia, and she did mixed method and she did EMOS, I think. But her work is mostly cited for SME research and performance, SME performance. Quite good for problem statement. This is a recent PhD student of mine who graduated last year, I think. So you can see a lot of the new things I discussed in my slides. She has actually incorporated that. So if you want to look at the most current reporting procedure, you may refer to thesis 0A, 0A by Shari Dato. Number one is a thesis from Australia, which I ended up an examiner. This is an interesting thesis on how to present your gap, which I find very interesting. You can look at the thesis. She presented her gap in terms of a diagram, which I find very easy to understand. Number two is the EO thesis, which is good for significance of the research. This was a thesis which was chaired by Joseph Hare at Kennesaw State University. Okay, this is actually a DBA thesis, but it's good for significance of the study. Number three, Collot thesis is from Brunel. This is good for theory. He has one chapter on theory, strength, limitation, and so on. And then he has also discussed about research philosophy, which I find missing in many theses. Research philosophy, positivism, interpretivism, pragmatism, confirmatory, exploratory. Yeah, those kind of things is discussed in Collot thesis. For those who want to do scale development, this is a thesis from USA. I think the name is Jalin Yi, I think. Her paper is already published in 2009, which is actually, this is on scale development and validation. That's a PhD by itself also, not the one where you have independent, just to validate a measurement can also qualify as a PhD. The other theses you can look at, but they are coming from other countries. You can look at them as a comparison, but you don't have to use them as a template, but you can look at them. Okay, yeah. Okay, for those who don't have SmartPLS, you can use this folder to install. This is the latest version of SmartPLS 3.3.3. And those who want to install process macro to your SPSS, I've also provided them here. Okay, number 11 is a list of indexing, which is used in many parts of the world. We have Social Science Citation Index, Science Citation Index, ESCI, HCI. We have also Scopus, we have ERA, we have ABDC, we have ABS ranking, we have FTSE, and also Singapore Tier Journal. So most of them are here. I'm not sure which ranking you use, but in Malaysia, we follow Scopus and Clarivate Analytics, which is SSCI and SCI. Okay, SSCI and SCI. So you can look at them. And this is a folder of other software if you want to explore. Adanko is another software you can use for PLS. JASP is a good software they have developed, which is freely available, and you can do a lot of things. I also attended a workshop to learn some of the analysis available with this software called JASP. SAM-IN-R is another free software developed by Somia Ray from Taiwan. But this one you have to know syntax, SAM-IN-R. And the last one is a WattPLS 7.0. You can install and try for 3 months. Okay, install and try for 3 months. Okay, so those are some of the additional software you can look at. So for those who don't have SPSS, I've given you the SPSS 26, which you can use. This is a crack. You have to do some cracking, and then you can run most of the analysis you need. And these are some calculators available for other things. When we do second order, we will need to use this AVCR calculator. Previously, we don't get effect size calculation, so that's also here. So that we will look at when we start doing the hands-on. Okay, yeah. Any questions on the materials before we start looking at the software? Yeah, any questions? So everybody's clear? Everybody has everything?
Yes, thank you.
Clear.
Okay. So
it's a gold mine, Prof.
Yeah. So you can take your time to look at it. Okay, so we will start the software, and I will show you how to check whether your software is working or is the student version. So we will go to Let me start my software. Okay, where's my Smart PLS? Okay. So this is how the Smart PLS 3.3 startup page will look like. No? Okay. And before you do anything, you can actually check your version by clicking this button called Info. And there's a button About. No? Info About. Okay. Click the button Info About. No? And what will happen is they will give you your license information. Okay, this is my license information. No? Smart PLS version 3.3.3, and the license expires in 40 days. Okay, the license expires in 40 days. So if you have license information which tells you license never expires, that is student version. Anybody with that license?
No.
No.
I don't have.
Everybody has the full license. Huh? So if you have the trial version, they will show you 31 days. If you started today, if you started yesterday, today they will show you 30 days. Okay, that's how the licensing information is given. Huh? Okay, the other thing you need to do is anytime you use this software for your analysis, you need to have this citation in your reference. Huh? So I'll highlight here this part here. According to the license agreement, it is mandatory to cite the use of Smart PLS in scientific publications. So if you are writing a paper, when you say we use Smart PLS 3.3.3 for analysis, in bracket you have to put Ringler et al. 2015. That's a requirement. Yeah. Okay. Make sure you do that. No? This is actually a mandatory requirement. Many people are not aware of. Okay. Yeah. That's license agreement. No? Okay. For those who want to switch license later, what you need to do is after your license becomes student version, you click this switch license, click the change license, and when you click the middle, you can put the license information here. Press the continue, they will update with the internet. You must have internet connection the first time for them to communicate with the server in Hamburg to activate the licensing information. So the license I gave you will start only when you activate. So it will give you 62 days from the day you activate. Okay. But what happens in many workshops is people tend to share with their friends. And then by the time another person wants to activate, they will tell you the license limit is reached. That's one of the problems with many Asians participants. They like to share things. So the license is for one person, one PC. Okay, so you can keep the license and activate anytime. Okay, it doesn't have an expiry date. Like if you buy today, it starts from today. No, so the license has 62 days from the day you activate. Okay, from the day you activate. No? So the license is a very long license key, like this. You see, this is the license key. Okay, quite long. So those who have the trial version, they will tell you trial version. They won't show you the license key. They will say to show you the trial license, right? Okay. And for those who want to use other language, they also have other language. Now they have Urdu was translated by Mumtaz, I think. Okay. And then we have Malay version. We have Persian version. I think Arabic also is there. Okay. So those are language options. Okay. Okay. So hopefully everybody is ready for the hands-on. Okay. The slides is here. So I will show you. These are some of the exercises we will go through. So the first one that we will do is this one, which is So what I've done is for each data set, I've given you the name at the top there. So the file name for this particular model is called path, and the sample size is 90. That's the information I've given. So in this model, we have 3 independent variable, 1 dependent variable. So if we see for single item, there's no arrow pointing outwards or pointing inwards. Okay, there's only one flat line, right? Okay, this is what they have changed in the newer version. Earlier, they had the arrow going out and going in. Single item, they actually measured by themselves. So here, this is like your regression, they actually scores, and we want to predict pie sales. So we have a price, we have advertisement, and also number of hours you spend selling. So when we develop models like this, the first thing we will do is we have to write the hypothesis. So the price and pie sales, the expected sign for this arrow will be negative. Okay, when price goes up, sales goes down, right? So the expected sign for this arrow will be negative. The expected sign for this arrow, which is advertisement to pie sale, will be positive. And the expected sign for sales time and pie sales will be positive. So we are expecting a negative relationship here, a positive relationship here, and a positive relationship here. Okay, that's what we are doing. So one of the things many people have problems with is interpreting the model. So when we have a model like this, we have 3 independent variables, 1 in the center and 1 at the end. And we have to write the hypothesis based on our prior knowledge. So we write hypotheses which are like this. How many of you write hypotheses like this? Yeah, everybody?
Yes, bro.
Yeah, okay. Nastaran, Abid?
Sometimes we change.
How do you write?
Depending on the, relationship.
Yeah, okay. Let's say positive lah.
Positive, significant relationship.
Oh, I don't. Significance is not required in the hypothesis, Abid, because that comes after.
Yeah.
Okay. So this is how I usually write my hypothesis. But in one of the colloquium I attended with a lady called Jane Klobas, she said, if you write hypothesis like this, there's no way you will know which is the independent and the dependent. Can you identify from here?
Yes,
You can't, right?
It has positive impact on something.
Okay, okay. So what she suggested was system quality has a positive effect on satisfaction. Then you know which is independent, dependent.
Yeah.
Okay? So I'm also trying to change. So, but that's how many people write, because in journal papers also you see the same format, okay. But it makes sense, if you write system quality has a positive effect on satisfaction, you don't have to double guess. Here we need to know the model first before we look at which is independent, dependent. In some papers they don't even show you the drawing, so that's where this comes in. Okay, so we have these 4 hypotheses and we got these results. Okay, based on this result, we have 4 hypotheses. Which hypothesis is significant?
Number 1, 2, and 4.
Yeah.
Number 1.
Yeah, because you have already attended many times, Nastaran. Right? Okay. Okay. This is one of the problems you find with many PhD students also. The results you get in a software called SPSS and AMOS is based on 2-tailed p-values. Automatic. You have no option to change them. It's actually based on 2-tailed p-values. What you need to do is you have to manually divide by 2. Okay, the p-value if you want to test for 1 tail. So the 0.063 for the first one, you have to divide by 2, you get 0.036. Okay, 0.036. Then no, 0.03. Yeah, no. 0.031. Okay. And 0.08, you divide by 2, you get 0.04. They're actually significant. Or else what will happen is, if you go directly by the p-value, you will say this is not significant, this is not significant, and the only one significant is the last one. Okay, this is what I normally get in many other workshops. Okay, because the training was just look at the p-value, and if the p-value is less than 0.05 is significant. If the p-value is greater than 0.05, not significant. But unfortunately, the software doesn't know you are testing one tail or two tail. Okay, but Smart PLS have recently introduced that function where you can pick whether you want to test for one tail or two tail. Okay, previously we don't have that, right? Okay, but in MOS and SPSS, they are by default two tail. You have to manually divide by 2 before you report. Now for APA reporting, 7th edition, you have to report p-value to 3 decimal place. Okay, 3 decimal place. Okay, so this is interpretation. So before we start looking at this. Okay, so we have 3 independent variable, 1 dependent variable. So what we will do next is we will draw this model in your Smart PLS for those who are first timers. When we start the model, okay, to start a new project, we will click project, and then we can give any name. So I put Oman 1. Okay, Oman 1. Okay, you can use any name. This is what we call as the project name. So if you are doing research on green supply chain, you can write green supply chain. If you are doing on retailing, you can say consumer retailing. That also is acceptable. But for this, we will use just Oman 1. Okay. So once you give the name, you click OK. Okay. So what will happen is they have already created a project here called Oman 1. Okay. A project here called Oman 1. And this is the drawing page, which is this canvas. Okay. For Smart PLS, you have to draw in the canvas. You actually don't have to draw, but just drag and drop. Okay. We still don't have the data file attached to the drawing. So what we need to do is, there's a button here called double click to import data. Okay. Double click to import data. So once you double click here, they will ask you where's your data. So what you need to do is you go to desktop where you put your folder. Our folder is February 2021, right? PLS basic. Click this and go to dataset. Then they will show you all the files available for you to attach. Anybody having problem? Again, so here we have a double click to import. Double click. And go to the folder called desktop. Okay, I have February 2021 PLS basic and data set. Okay, the file we want to open is path. Path. Okay, once you click the file name, you can click the button open. So it will tell you we are trying to import the data file called path. So if you have SPSS file and all, the software will not recognize. You need to first convert them from SPSS into CSV, .csv before we can attach. Okay, again, before I forget, you must remember all structural equation modeling software, most of the structural equation modeling software cannot do data entry, cannot do data screening, cannot do data filtering, cannot do recoding, cannot do anything except for modeling. So most of the process involved for getting the data ready for analysis happens with a software called SPSS. Okay, SPSS, missing value, straight lining, recoding. If you have dummy variable, you have to do recoding to dummy variable in SPSS. before you can convert into CSV and read into Smart PLS. So once you have attached the data, when you click OK, they will show you here. The file is now showing you your data. Okay, the data has 90 records. That means your N is equals to 90. And another button they have introduced here is called missing value. So if you have a missing value and you use some numbers like 99 or 999, you can click this and put in the number that you use as a missing value marker. Okay, missing value marker. If you don't have, and I suggest you do the missing value replacement in SPSS before we transfer them. We see here there's no missing value. All of them are okay. Yeah, is everybody having the data? Abid, anybody stuck anywhere? Everybody's okay?
It's green.
Yeah? Everybody's okay?
Okay, Prof.
Okay. Okay. So this is the data file, and they will give you a descriptive, mean, median, minimum, maximum, standard deviation, kurtosis, skewness. Okay. Those are indication. So to begin drawing, you have to, for those who don't have the numbers coming out, what you can do is you just click this button, reanalyze, and then the numbers will come out. Okay. For those who don't have the numbers coming out. So to start drawing the model, you need to click Oman 1, which is the drawing. The circle with the 2 items, right? That is called the drawing. So once you click the Oman 1, you get a screen like this. Okay. On the bottom left, you have all the indicators you need, right? Okay. This is the model we want to draw. Price, advertisement, sales, time, and pie sales. So the first variable is price. So what you do is from here, just drag and drop somewhere. Okay. Price, advertisement, hours. Oh, pie sales is supposed to be here. Sorry. Price is supposed to be right. Okay. This is the arrangement. So I will make it bigger a bit. So if you want to move the item around, just click on the circle, pull it where you want. When you're happy, then you let go. That's how the movement works with the lorry in Amos. In Amos, you have a lorry, right? You have to click the lorry to move some of the items. Here, you don't have to. They move with the circle. Just drag the circle around. Okay. Yeah. It's, okay. So just drag and drop. And what we need to do is once you drag and drop, okay, there's an item here which is pointing to the left. We want to move the item to the right. So what you need to do is you right click, and then we have align indicators to the right. Align indicators to the right. That will move the item to the right. To the right. So I'll make it bigger a bit so that you can see clearer. You should be able to see it now, right? Okay. Okay. So that's how you drag and drop the item for the model. So next, what you need to do is you have to connect the variable. To connect, there's a button here called Connect Latent Variables, or you can press Alternate and F3. Yeah, Alternate F3. Yeah. Okay. If not, you just click here. You have to press your left mouse, drag until the second variable, and click. So if you drag this way and you click until tomorrow, it will go back. It's not connecting. So you need to connect from here to here, the second variable and the third variable. Okay, once you connect the third variable, you see the color changes. So what it's telling you is now you have a valid model that you can run your analysis. A valid model that you can run your analysis. Okay, is everybody on the same page? Yeah, anybody with problem? Everybody's okay?
Yes, so far, Prof.
Okay.
Yes, yes, Prof. Thank you.
Okay. So once you have done everything, what you need to do is the arrow is still there. We see the arrow following you. What you need to do is just click this button, select, to remove the arrow. So now there's no more arrow, right? Okay. Okay. We want to change the name of the latent variable. Now it's labeled as latent variable 4, right? You can press the button F2 or you can right click and rename. Okay, see the F2? Okay, you can do both. So if you press F2, then change the label to price. F2, we can put it as advertisement. Advertisement. And the final one is sales time. And this is that is to change the name of the latent variable. So if your name is too long, just make the circle bigger a bit, then you're okay. So you can also pull this up a bit so that you can see clearer. Okay, so that's how you change the name. Okay. And one of the other thing I like to do is instead of using this color, I like to use the black and white, which is more sharper and easier to see. So to change the color together, what you need to do is you click this button called More Themes, go to black and white, and then apply. Okay. More Themes, black and white, and then apply. What will happen is everything will change to which is like this, which is much more sharper. They changed the coding. Previously, it was not so dark. And now they've changed everything to quite a dark color. Okay, so if you print this out, it looks very nice. Yeah. So that's how you change the look. Okay, if you want to change the font's border size, you have this template here, right? We can change the border size. To do alignment, you can also do it from here. This is if you can do selection 1, 2, and 3. Just press the Control key and click on the 3 circle. And if you want to align them, align selected elements to the left, right? Just click here. They will do the alignment for you. So those are some of the things you can do it here. If you want to change to bold, you want to change color for the circle, everything is given here. So this is what we call as the palette. So if you want a grid, you can also click here. They will show you a grid like this. If you don't want the grid, you can do this. If you don't want to see this, just click this snap. No. Click this. It will disappear for a while, and then you can click this to come back. Okay. This how you can make it disappear. Okay. So this is the drawing. So first, after you draw, you have to click this button to save, so that the next time you come back, you can actually rerun the model anytime. So once you click here, it is already saved. Okay. Okay. The other thing I would like to also mention is if you want to send this model with the data together to your supervisors or your co-authors or your co-researchers anywhere in the world, what you need to do is you have to click on this Oman 1 project name, not this one, Oman 1 project name. Okay, Oman 1 project name. When you right click, you have export project. Export project. What it will do is it will now zip up the data file and the drawing and save as oman1.zip. Okay, you can try that. Just click export project. So we see they were saved in the folder called dataset. Just click save. So this is actually now already saved. This is for those who have many projects running and you want to move your project around. You can save the project and take it wherever you want. Okay, that's for exporting your project. No? This is something you need to do as backup. No? Sometimes the program gets corrupted. So if you want your data back, what you can do is you can go under File, Import Project from Backup. Okay. So we can read that Oman 1 file directly to the folder, okay, with the data file, everything. That's a good thing about the export project, huh? And then you can email to anybody you want, and that person don't have to redraw. Just import, and then they can run the analysis. Okay, yeah, that's the first thing. Huh? Okay, the second thing is if you want to copy and paste this drawing in your Word file, okay, or PowerPoint file, right? What you do is you right click, and you have export image, export as image to clipboard, export as image to clipboard. If you click the first one, export image to file, you have to save it first. Okay, then only you can open. No? This is a temporary folder they create. Then you can go to any software to right click and paste. Okay, so if you click the export image to clipboard, go to your Microsoft Word. Okay, and open it first. Then we can click right and paste. So what will happen is you get the drawing here, the same one we drew in SmartPLS. We can put here figure 1. Okay, so that will become your research model. Everybody okay? So that's for copying pasting. Huh? So you can do all the modification in your SmartPLS and then send them to another software. Huh? So if you don't want the item to be displayed, you can also do this. Okay, press Control A, and then you have alternate ALTC and ALTX, I think. ALTX is to hide, ALTC is to show. Or you can also alternatively click right, and there's a hide indicators. This is normally done for models which are large. You want to hide the items for a while. So just hide the indicators, and then you right click again, show indicators. So that's how you can hide and show the indicators of your model. Okay. So once everybody is ready, then we will move to the next stage. Okay. Control A. So I want to move it up a bit so that you can see clearer a bit. How come it's not? Okay. Yeah. Okay. Everybody is ready?
Yes, Prof.
Okay. Okay, so once we have saved this, for calculating, we can use this button here, calculate, or this button here called calculate. Both will give you the same thing. Here, calculate, or here, calculate. Okay, so calculate, we will go to PLS algorithm. Calculate PLS algorithm. Okay. So at the moment, they have already set for you the best possible combination. You don't have to change anything. When you become more cleverer, you can change whatever you want. At the moment, we will follow the guideline. The only thing you change is this. At the moment, yours is open full report, correct? Okay, open full report. Just change this to close calculation dialog. Okay, close calculation dialog. Okay. What is the difference is they will run the model and then they will show you your drawing. Okay. If you put open full report, they will show you the text output, which is you have to move forward and backwards. Okay. So this is what you need to change. That's it. And then you will click this button called start calculation. Okay. So here, since the variable is measured by the score, the loading will be 1. Okay, the number on the arrow. This depends on whether the arrow is going out or the arrow is going in. If the arrow is going in, we call them weights. If the arrows are going out, we call them loadings. Okay, so the loadings will all be 1. But when you have multiple items, the loading will range from 0 to 1. Okay, 0 to 1. Okay. The number on the arrow here, we call them the standardized beta, standardized path coefficient. In SPSS, we will have unstandardized and standardized, but in Smart PLS, they only give you the standardized beta coefficient. So if you see a negative sign here, what it means is when price goes up, pie sales goes down. Okay, but we don't know whether it is significant yet. So the beta value is an indication how strong is the relationship. Okay, closer to 1, ignoring the sign. Closer to 1, the relationship is strong. Closer to 0, there's no relationship. That's how the beta value tells you the strength of the relationship. So out of these 3 beta values, we can know that this is the most important variable in pie sales. So if you have more advertisement, your pie sales will have more pie sales. That's it. Okay, that's what the beta value is saying. And inside the circle here, it is giving you the R square. Okay, it's giving you the R square. So what it's telling you is all these 3 variables put together, you can explain 52.7% of the variance in pie sales. All the 3 variables taken together. Yeah. Any question? Yes. Any questions on the numbers given in this drawing? You have your loading weights from construct to item. From construct to construct, we have the standardized beta values. And inside the circle, they're actually showing you the R square. Okay, the R square. So that's how you look at it. Okay. Okay, how do you interpret the beta values? Numbers on the board tells you that any beta value from 0 to 0.1, they are very weak. They should not be significant. 0.11 to 0.19, we call them marginal. We are not sure yet. Okay, it depends. And any beta value more than 0.2, they will be significant. Okay, they will be significant. And here the T values are not shown directly because we will do a procedure called bootstrapping. Okay, we will do a procedure called bootstrapping to get the T values. Okay. Yeah. Any question? Okay. Everybody okay?
Yes, thanks, Prof.
Okay. So we will move to we will move to calculating the bootstrapping. So when you go to calculate, we will now move to the second one. Earlier we did algorithm. Now we will do bootstrapping. Okay. Okay. So why bootstrapping is employed in Smart PLS is the assumption is data is not normally distributed. But I will show you how to assess the normality later with a full set of data. For at the moment, what the software will do is we will suggest the software to do bootstrapping. Okay, and the subsample suggested by Hare et al. Is 5,000. So you can change it to 5,000 subsample. Okay, what is meant by 5,000 subsample is we have 90 cases, right? What was the sample size? Let me see.
I think 90.
Yes, 90, Prof.
90, right? Okay, so our sample is 90. Yeah? So when you click here 5,000, what you're telling is now the software will select 5,000 sample every time 90 cases. Okay, first sample will have 90 cases, second sample will have 90 cases, and they will do this 5,000 times. And the calculation of the beta values, the standard errors, the t values, everything is done by the bootstrap procedure. Okay, so the t value will be calculated based on the bootstrapping. Okay, so that's what bootstrapping means. Huh? And the bootstrapping subsample must be same as or greater than your sample size. Same as or greater than your sample size. That's a requirement. Huh? Okay, so the amount of result, we have two options here, basic bootstrapping and complete bootstrapping. Okay, here we don't need, we can actually ask for complete bootstrapping. Okay, when you click the complete bootstrapping, here they give you the explanation. Basic bootstrapping will only give you all these outputs. Okay, these outputs. But the complete bootstrapping will give you more outputs.
Alia?
Okay, additional output. Okay, so those are the difference between basic and complete bootstrapping. Okay. For confidence interval method, we have three of them: percentile bootstrap, studentized bootstrap. Most researchers use bias corrected and accelerated. So we will stick to this. And the test type, we will change to one tail. Why we change to one tail is later when we report, the p-value will be already divided by 2. Will be divided by 2. You don't have to do that manually. Okay, you don't have to do that manually. Yeah. So those are some of the settings. Okay, and then we can click start calculation. Okay, what happens now is the software will give you t values. T values. So if you have multiple items, they will also show you the t values for the loadings and the weights. Here, since the single item 1.0, right? So that's why the t values are 0. Okay, the relationship between price and pi sales, they are significant because one tail, the cutoff value is 1.645. 1.645. That's the cutoff value for 5% one tail. So anything greater than 1.645, they are significant. Anything less than 1.645, they are not significant. Okay, so that's where this number comes in. And you will have slightly higher or slightly lower number than mine. Not an issue, because this is a random sampling process. So one of the suggestions is before you start reporting your results, you must save the data, the output, because if you close and open again and you run bootstrapping, you will get very different t values. Okay, very different t values. So it's always better for you to save the output file before you start reporting. Okay, here the second one, advertisement and pie sales. You have 12.533, which is greater than 1.645. So this is significant, and 1.116 is not significant. So only 2 variables out of the 3 variables are significant in this model. Okay. Any question on the interpretation?
No.
Okay. Okay. So for saving the output file, here we have these 4 formats. Number 1 is called report. A report will show you temporary files. If you click this Excel file, what they will do is, you can try that just to show. Click the Excel file, and then you click Start Export, and just save. So what will happen is, they will export all the output that you ran just now for bootstrapping into an Excel file. Okay. So they will save the file in an Excel format, and they will open the file like this, which is actually the same output you'll get later. Okay. So on the navigation panel here, we have tabs, right? This is the navigation. If you want to see the complete report, just click the complete report. They will show you all the report. And if you want to see all the charts here, okay, these are the charts that they will give. So from the navigation panel, you can jump into to see any of the output by clicking here. So if you want to see adjust the R square, just click here. They will show you the R square here, right? This is the R square. R square, right? Okay, 527, 0.527. So to go back, you just click the navigation. They will bring you back to this page. So this is the Excel file for your output. If you want to look at it. So the other thing you can look at is this button called report. Okay, this report. This is a temporary file that is now giving you color coding. Okay, this is these are what we call as hyperlink. If you want to see any of the R square, you just click R square, they will go to R square. If you click path coefficient, they will come back here. So any value you want to look at, just click here. They will show you up here. So here the header tells you what you are viewing. What you are viewing is given in the header, path coefficient. These are the path. You can pull it a bit, then you can see. Okay. Now they have this color coding in the software after 3.2.9, I think. Before that, they didn't have color coding. So the color coding, green means significant, red means not significant. Okay, green means significant, red means not significant. Okay, so the third one, you can already see the color, right? If you are colorblind, then too bad. So many people have problem with numbers, greater than, smaller than. So what they did was now they come up with color. So if you have problem with number and color, then I don't know what other things they can do. So here the color coding, you can refer to the book by Hare. Anything he says as cutoff value, that's the number they follow. Okay, that's the number they follow. So here we have advertisement to pie sales, which is significant. Price to pie sales is significant. Sales time to pie sales, not significant. Okay, that's what you get here. Okay, yeah. Any question on the output? Okay, so that is the output that you get. And some of the other outputs here, they are not very useful because this is actually multiple regression, okay, where you have variables which are measured with scores. That's why you don't get much input for analysis. Okay, so if you want to report this, what you can do is just click this button called Excel format. Okay, Excel format. So I will show you how the reporting can be done. Click the Excel format. Go to your Excel file. Okay, open the Excel and paste in the second column. Paste in the second column. And I'll make it bigger. And this will become bigger. Okay, and then we can centralize them. I normally like to change the decimal to 3. That's a requirement, right? Okay, so just copy and paste. And there's 2 columns here, original sample and sample mean. You need to listen to my explanation. Okay, what is the difference is the original sample is the beta value you get from your data set. The sample mean is the bootstrapping. When we run 5,000 times bootstrapping, every time we get a different beta value. Average of the 5,000 bootstrapping average is given here. Okay, this column is not needed for reporting. Not needed for reporting. So we will right click and delete this. Again, okay. So we will delete this column called sample mean. The sample mean is the bootstrapping beta value from the 5,000 bootstrap that we ran. Okay, that we ran. So this is not needed. Okay. So the first one we will change to standardized beta. Second column we will change to standard error. Third column will be t value. Fourth column will be p value. And we will write here BCI UL and BCI LL. Okay, so okay. For reporting, we also need this confidence interval bias corrected, the lower limit and the upper limit. Okay, lower limit and the upper limit. So where do you get them? We will go back to the report. This is what we copied just now, right? Mean, standard deviation, t values. So what we will do now is we go to confidence interval bias corrected. Okay, we have a confidence interval and we have a confidence interval bias corrected. The one we want to report is confidence interval bias corrected. So when you click here, you will be given this 5% and 95%. Okay, 5% and 95%. So the confidence interval is actually 90%. Since it's one tail. If it's two tail, the confidence interval will be 95%. Okay, 95%. We need this lower limit and the upper limit, but we cannot copy just these 2 columns. So the same thing you do, click the Excel format, go to your Excel, paste it here. Okay, and we only need these numbers, which is the lower limit and the upper limit. Okay, lower limit and the upper limit. So you can copy and paste just below here. And center, right? Okay, done. Huh? So that's the reporting. Huh? And the other value we need to report is the F square. F square. Can you click the F square? Okay, we actually need the first column only. Huh? The first column. Huh? Okay, the effect size measures how important is the variable. So now for significance, we have two types of significance. Number one is called statistical significance. Number two is called substantive significance. Substantive significance. So for substantive significance, we will look at the effect sizes. Okay. So the effect sizes, we have three levels. 0.02, we consider them to be small effect. 0.15, we consider them to be medium effect. And anything larger than 0.35, we consider them to be a strong effect or large effect. A large effect. That actually measures how important are those variables. Okay, those variables. So we will copy this table first, Excel format. And when we come to the Excel table, we will paste it here. We only need this first column. We will copy the first column and paste it here. And change the label to F square. F square. Okay. To complete the table, we will write hypothesis here, and then H1, H2, and H3. Okay, so we will, here we can pull it a bit, and here we will put relationship. Okay, so that's how we can develop the table to be reported. So here, for a long time, what we have done is we stop at this. We normally stop at this column called T values, and then we put 1 star, 2 star, and then you finally see stars, right? Okay, that's not required anymore. That's not required anymore. Now you have to report P value to 3 decimal places. Okay, that's the first thing. So you cannot stop at T values. You need to add another column called P values. And then to assess whether the variable is significant or not, we will use 3 criteria. Number 1 is the P value. Number 2 is the confidence interval. And number 3 is the effect size. Okay. If all 3 agrees, then you have a stronger evidence that variable is actually important. Okay. Yeah. So the P value tells you these 2 variables are significant. The confidence interval, you have lower limit positive, upper limit positive. Here, lower limit is negative, upper limit is negative. So these 2 confirms. Here we have a negative and positive. So in between we have a 0. So this should not be significant. And effect size tells you this is large effect. This has very large effect, and this one has no effect because it's less than 0.02. Okay, 0.02. So when you have a 0 here, you don't have to report 0.000. What you can do is you put a P less than 0.001. Okay, this is the new format for reporting your P values. when they are zero. When they are zero. Okay. Yeah. Yeah. So that's how you interpret the table. Yeah. Any questions on how to report and interpret this table?
Prof, can you just repeat this one? BCI upper limit and BCI lower limit.
Okay.
And
this part, this part, right?
Yeah. Yeah.
So I will highlight first. Okay, for a long time, we have been using p-value as the criteria for significance. But there's a lot of literature saying that p-value can be manipulated just by increasing sample size. Okay, in the folder I shared, there's a paper titled Too Big to Fail. Too big to fail. That means if you have a sample size of 1,000, everything will be significant because your standard error will become very small. Okay, that's one of the reasons why they don't trust p-values. They have actually suggested some papers to change the p-value to 0.001. Okay, 0.005 instead of 0.05. They have suggested to change to 0.005. And another group of people say you don't have to change, but you have multiple criteria. Okay, so the other criteria they have suggested is this. BCI-UL and BCI-LL. Okay, this is for a variable to be significant. The lower limit and the upper limit should not straddle a zero. That means lower limit, upper limit, if in between there's a zero, then they should not be significant. So here we have a positive and positive. Here we have negative and negative. And here the last one, we have a negative and positive. So in between there's a zero, right? So that's why this is not significant.
Okay.
Okay.
Understood.
Okay. Yeah. And the last one is the effect size. Okay. We have the three criteria, 0.02, 0.15, and 0.35. These are given by Cohen. And there's a recent paper written by, there's a recent paper shared by Aguinis, which is also talking about this. Maybe I will try and look for it. But based on Cohen, these are the numbers. Anything 0.02 up to 0.14, they are small effect. 0.15 to 0.34, they are medium effect. Anything 0.35 and above, they are large effect. That means very important variables. Very important variable. So the p-value is significant. The confidence interval confirms that. And the effect size also tells you these two variables are important. So now we will use all these three criteria to make the decision. Any question? Abid?
No, Prof. Thank you.
In the future, they will also change this. Now they are saying the test we are doing is called null hypothesis testing, NHST. They're actually questioning this. In the future, they will start introducing another criteria called Bayesian criteria. Okay, I'm trying to attend some workshop, but very difficult to understand what they are actually doing. Okay, so that is the next stage. Okay, that is the next stage. Yeah. Any questions so far?
No problem.
Okay. Shall we take a break and then come back a bit?
Yeah, sure.
So we will stop here for this, and then we will come back at 4, right? A bit your time.
Or 4 o'clock. Yeah. Yes, our local time 4 o'clock.
Oh yeah.
Yeah. Okay.
Thank you. Thank you.
Thank you. Yeah.
Thank you.
Thank you.
Okay. Sorry for clock. So we will continue. Okay. In your folder called PLS Basic, under the folder called reference article, if you go, there's a paper called JWB, yeah? Number 180, yeah? Number 180. This is actually an editorial paper written by the editors of Journal of World Business. Huh? Okay, this is some of the changes happening in the reporting. Huh? Remember I was telling you about the changes happening? So this is where they talk about the changes here. This is the question. Huh? One might ask what simple decision rule will replace the P less than 0.05 criterion. The ASA has demurred on this issue, and at the time of writing, there's no generally held consensus. Okay, various approaches are proposed. One of them is replication of studies. Okay, the use of effect size estimates and interval estimates, which is the one I showed you. Effect size estimates and confidence interval, and the use of Bayesian methods. These are the next generation assessment, which is Bayes factor and likelihood ratios and decision theoretic modeling. So those are some of the things being talked about in the literature. So you like it or not, these are some of the changes happening in the methodology. So at the moment, what I'm telling you to report is the most updated, but we are waiting for some new changes that will happen in the future. Okay, so those are some of the things. So we stopped at this model reporting. So we have finished reporting a path analysis. Okay, next what we will do is when you look at your this. So what I've done is, okay, I've summarized them in these slides so that you can straight away follow from here. Okay, the next kind of analysis we will look into is what we call as latent variable modeling. Latent variable modeling. What is meant by latent variable modeling is, let me see, recording is on, okay. What is meant by latent variable modeling is you have variables which are independent dependent, but they are not measured directly. Previously we had a single item, now we have multiple items. So when you have multiple items in your model, the reporting procedure is not like the first one we did where we have single item. Here we have to have two stages of reporting, which is the measurement model followed up by the structural model. So the measurement model will assess validity, reliability, and the structural model will test whether the hypotheses that we develop are actually significant. Okay, are actually significant. That's where the two stages comes in. So for reporting in Smart PLS, I actually summarized them into these 4 steps. Number 1 is called the normality analysis. Okay, the normality analysis I'm talking about is not the univariate normality. I'm actually talking about multivariate normality. Okay, for a long time, people have not reported multivariate normality at all when they run structural equation modeling. Okay, when you run your regression analysis, you have several assumptions that you test, right? Normality, linearity, multicollinearity, constant variance, outliers, autocorrelation. What else? What is that? Okay, all those assumptions you test rigorously, yeah. But suddenly when you move to structural equation modeling, you don't test anything at all. No, everything is dependent on whether the p-value is significant or not. We are still running multiple regression. By the way, we are not doing rocket science. We are still doing multiple regression. Only thing we are running them simultaneously. So all the problems that you found in your normal multiple regression analysis in SPSS, they are still present in partial least square and also your AMOS modeling. But unfortunately, what I'm noticing now with many PhD students and researchers is they have forgotten all about the assumptions. Now it's only about significant, 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 and fit, fit, and fit. That's it. Okay. But your model can fit, but your data is not normal. Your model can fit, but you have multicollinearity problem. So that all need to be addressed. So for multicollinearity in Smart PLS, we can do that. But normality, Smart PLS doesn't give you any values. So we will use a website for that particular analysis. The second one is called common method bias. This is also ignored a lot in many papers and also thesis because candidates are not exposed to this. For a long time, we have been trained to collect data from a single source, run the analysis, nobody questions them. But recently, when the last 2-3 years, when I started submitting to good journals, the first question they ask is, you have single source data, how do you address this common method bias? That's where we will also look at this testing of common method bias. I will show you 2 methods. One is full collinearity testing, where you don't have to collect additional data. The second one is marker variable testing, which you have to collect additional data. Okay, both I will show you. Okay, step number 3 will be the measurement model. This is where we will assess validity and reliability. And finally, the structural model, okay, where we test relationship. Okay, for normality, this is the website that we will go to test normality. Web Power Psychstat kurtosis. Okay, here the website, you have to upload the data, and what the software will do is they will give you univariate normality and multivariate normality. Univariate normality is not important because we are not doing t-test or one-way ANOVA. Okay, we are not doing t-test or one-way ANOVA. So univariate testing is actually not important. And what I find is many people report univariate normality rigorously and ritualistically. Okay, but you are not doing one sample test, right? You're not doing t-test or one-way ANOVA. You're actually doing multivariate regression, right? So when you do multivariate regression, the important assumption is multivariate normality. So for multivariate normality, we can assess multivariate skewness and multivariate kurtosis. These are not available in SPSS. These are not available in PLS. This is only available partially in AMOS. The second one, multivariate kurtosis. They don't have multivariate skewness also in AMOS. Okay. So after 2017, these authors called Kane et al. 2017, they published a paper reviewing all papers published on using structural equation modeling and regression, and they found that most papers don't report multivariate normality, whereas that is the most important assumption that you need to pass in when you do parametric analysis. So Klein 2011 gives you this cut of values. For multivariate skewness, we can accept up to ±3. In some literature, they give you ±1. We can also accept up to ±3. For multivariate kurtosis, the cutoff value is ±20. Okay, ±20. Yeah? Okay, anything greater than those numbers, the data is not multivariate normal. Okay, not multivariate normal. So that is the first test we will do. Okay, the first test we will do. Yeah. Any question on the multivariate normality? Yeah.
Sorry, Prof. We should upload our data in this website.
Yeah. Later I will show you. But we have to finalize the measurement model first before we can do number 1 and number 2. Okay. But the reporting will start with number 1, and then we move on to number 2, number 3, and number 4. Okay. Number 2 is this called common method bias. So we can do 2 tests. One is called the marker variable technique. This is provided you have collected an additional marker variable. If not, you can't do that. The second test we can do is full collinearity testing, which is given by Koch and Lin 2012. and Koch 2015. These are the two citations for full collinearity testing. Okay, so I will show you both, but for marker variable technique, you can go to the folder called reference article and then you type marker. I think you will get these papers. So I will show you how things are done in some papers so that you can see it clearly. Do I get it here? Okay, so I will pull it up a bit. Okay, yeah. So here we have several papers which are listed. Okay. The one you can look at is 234, 235, 244, and 322. 322 is a marker variable using color. Okay, but I will show you two, which is these two are the ones easier to understand. So number 235 is a paper written by Walter and Cronin, where they show you clearly in a table form. This is a paper in marketing. And what happens is, this is the paper. It's not showing. Sorry. I think it's not. Let me share. Okay, so this paper by Walter and Cronin, these are big names in marketing, right? Big names in marketing, Journal of Business Research. What they have shown is in this is the model they want to test. And if you see the construct, yeah, okay. These are the construct used in the model. And finally, bottom here, you see, marker variable. Okay, marker variable. These are the two items they use as marker variable for this study. Okay, for this study. And what they did was they showed them in a table form. This is one way of doing things. Okay, the other way of. Okay, let me share screen, right? Okay. Okay, the other way of showing the same analysis is 234 here, right? Lin et al. Marker variable. Okay, what they have done is instead of showing them like the table given by Walter and Cronin, what they did was they explained in a paragraph. See here. Okay, this is a paragraph that talks about common method variance. So here they said we follow Potsakov et al. 2003. This is the approach called PLS marker variable. Okay, the three items they selected were once I've come to a conclusion, I don't change my mind easily, and my views are very consistent over time. These three items are coming from OREC 2003. Yeah, okay, and a variable name is actually cognitive rigidity. Okay, cognitive rigidity. Yeah, and they explain in sentence what they did. But it's very difficult to understand. But I will show you how this can be done in Smart PLS. Okay, so these are the two papers that you can see quite clearly the use of marker variable. Okay, because every time I do workshop, the participant will tell me I have not seen a single paper in my life that uses marker variable. So at least now you have seen some examples of marker variable. So if you want to see a paper that summarizes some of this testing, is I think there's a paper. Okay, we go to Ramaya PLS articles, folder number 1. I think there's a paper by Shehnaz, I think. Let's see. Do I have it there? Yeah, okay. Number 27 in the folder called PLS article. This is a paper written by one of my former PhD student now working in Sunway University. So she has written a paper on testing and controlling for common method variance, a review of available methods. But this was written in 2017. She didn't have, I'm not sure whether she has full collinearity, but all the other methods she have actually covered in this paper. So if you want to understand better the issue of common method variance, common method bias, you can look at this article. Okay? Look at this article. So that's number 2. So number 1 and number 2 can only be done after you finish number 3. Okay, number 3. So number 3 is this. We call this the measurement model validation. We will divide them into 2 parts. The first part is called convergent validity, where we will look at loadings, composite reliability, and average variance extracted. Okay. For loadings, we have different cutoff values, 0.5, 0.6, 0.7, and 0.708. Okay. You can decide how you want to cut off. I normally cut off at 0.5. But the more important criteria is this called average variance extracted. Average variance extracted, this is fixed, 0.5. Anything less than 0.5, the measurement is not valid. Okay, the measurement is not valid. So this is a very important criteria. They actually related to the loadings. Okay, the loadings. So loadings you can cut off at 0.5, 0.6, 0.7, or 0.708. 0.708 is given by Hare et al. In 2017. Hare et al. 2017. But you don't have to follow this criteria. Okay, when you run the analysis in Smart PLS, any loadings less than 0.708, they will be marked as red. Okay, they will be marked as red. You don't have to delete them. You don't have to delete them. Okay, because the criteria is 0.708. Anything less than 0.708 is marked as red. But if your AVE is already more than 0.5, you don't have to delete items with loadings which are 0.5 to 0.7. Okay, 0.5 to 0.7, we call them marginal loadings. Not very good, but we can still tolerate if the overall average variance extracted is greater than 0.5. Okay. For reliability, we now have 3 criteria for reliability. The first one is called Cronbach alpha. But Cronbach alpha has been criticized by many researchers. There's a paper written, thank you, coefficient alpha, we will take it from here, which is telling you, rest in peace, Cronbach alpha. But there was a reply paper written by Makulaitis to that paper saying that, thank you, coefficient alpha, we still need you. So that kind of papers are still being debated. So what they're arguing is, in certain situation, Cronbach alpha is still useful. But in structural equation modeling, most researchers don't report Cronbach alpha. Okay, the one they report is composite reliability. Okay, composite reliability. Okay, composite reliability doesn't depend on sample size or number of indicators. For Cronbach alpha, they suffer from 2 issues. One is the number of indicators. Second one is sample size. As your sample size increases, Cronbach alpha increases. As your number of items increases, Cronbach alpha also increases. So if you have 2 items, 3 items, Cronbach alpha will be low. If you have 10 items to measure the variable, Cronbach alpha will be 0.9. Okay, that is one of the problems with Cronbach's alpha. So that's why now they use this composite reliability, which is called Dillon-Goldstein rule. Okay. Okay. The other reliability measure which is available in the literature is called ROE, which was developed by Hensela for an analysis called consistent PLS. So if you are not doing consistent PLS, you don't have to use ROE. Okay, ROE. So those are numbers for convergent validity. So the first part of the assessment will be assessing convergent validity. Once you pass that stage, then we move to the next stage called discriminant validity. Okay, discriminant validity. For discriminant validity, we have 3 things we have been using for quite some time now. One is called the cross-loading, but you can forget about cross-loading. I will show you the tables, how to interpret them. But cross-loadings are only useful as diagnostics, okay? Diagnostics, if you have a problem with discriminant validity. If you don't have any problem with discriminant validity, cross-loadings are not very useful, okay? Not very useful, no? Okay, for testing discriminant analysis, we have been using Fornell and Lacker criterion, which is 1981 for a long time. But this criterion has been criticized, and in 2015, this criterion called HTMT was introduced. For those who are reporting smart PLS, many researchers have started using HTMT criterion. Okay, no more Fornell and Lacker. For those who are doing AMOS analysis, they are still reporting Fornell and Lacker because AMOS does not offer HTMT criterion. But if you go to the website called StatWiki, which is maintained by a guy called James Gaskin, he has some add-ons that you can actually run HTMT criteria also for AMOS modeling, okay? Also for AMOS modeling, but you have to have some add-on, which is called the plugin, okay? The plugin, okay? So for discriminant validity, we will focus on HTMT. Okay, convergent validity focuses on items measuring the construct, okay? Items measuring the construct, whereas discriminant validity is focusing on the construct. Okay, let's say your model has 5 constructs. The idea is all these 5 constructs must be understood as different constructs by the respondents. But sometimes this doesn't happen because respondents don't understand the items measuring the construct. They think 2 of the constructs are actually measuring the same variable. So that is where you run into a problem called discriminant validity. So if your model has 5 variables, we want to assess whether the respondent understood you have 5 distinct constructs. That's the idea of discriminant validity. Okay, discriminant validity. Okay, for convergent validity, we will look at this value called loadings. Normally, I will ask this question to many PhD candidates. When they explain during their finding, they will talk about loadings. And then when you ask them what is loadings, the answer will be loadings is equals to loadings law. In Malaysia, we like to use the word law for emphasis. Okay, loadings are actually correlation between the construct and the indicator. Correlation between the construct and the indicator. So this is what we call as the loading. This is R. Okay, R. Okay, correlation between the construct and the item. If you square this, you get variance extracted, which is R square. R square. This is the R square for item 1. This is the R square for item 2. This is the R square for item 3. So when you take the average, they are called average variance extracted. Okay, average variance extracted. So the loading changes to variance extracted. The variance extracted changes to AVE. There's no magic about this. Everything is back to the issue of measurement. If your measurements are good, VE will be high, AVE will be high. They are all interrelated. Your composite reliability will also be high. So in this situation, if your cutoff value is loading greater than 0.5, this X2 we will retain, right? This is okay, this is okay, this is okay. That's your first stage of analysis. The second stage will be the AVE. So when we assess the AVE is 0.41, which is lower than 0.5. So since this is lower than 0.5, what we need to do is we go back to the model, delete this item, which is 0.5. So once you delete this item 0.5, you get an average of 0.5. 0.5 plus 0.5 divided by 2, you get a 0.5. Okay, so in this situation, you need to delete this item with a loading of 0.5. Okay, we can also have a situation like this. We have first item 0.7, second item 0.5, and the third item is 0.9. Okay, in this situation, this item we don't have to delete because when you square it, you get 0.49, 0.25, and 0.85, and the average variance extracted is greater than 0.52. Okay, greater than 0.52. That's how you decide whether to delete items further. Okay. But you don't delete until you have no items left. This is one of the problems I find with many researchers. They begin with 50 items in the model. They delete up to 25 items from the model and say, my model works now perfectly. You have already deleted 50% of your items. You're testing half your model, not a full model. Okay. But still, people are very happy with that. That's not a good thing. When you delete more than 20% of your item, that already questions your conceptualization and measurement validity. Full stop. Okay. Anything more than 20%. Yeah. Any question on how you assess loading AV and the CR? And
No.
the percentage of item deleted. Yeah.
No, it's okay.
Yeah. A bit.
Yeah, it's okay.
Huh?
No question.
Okay. Done. Okay. Okay, for structural model, these are the things we will report. One is the beta value, standard deviation, T values, P values, confidence interval, bias corrected, effect size, predictive relevance, we will report in the text. PLS predict, I will show you how to develop the table. Okay, I will show you how to develop the table. Yeah, James Gaskin. Yeah, James Gaskin. Okay, so that's what we will do. Okay, yeah. Any question on what I discussed so far?
Just one thing, Prof. For the marker variable, I mean, is it necessary to be theoretically unrelated or related?
Yeah. It should be theoretically unrelated.
Yeah.
You can look at different areas of study. For example, in psychology, they normally use a variable called, what was the variable? Social desirability. Okay, social desirability. But the questions are quite sensitive. So I actually don't like to use them. Most of my students will use the marker variable called cognitive rigidity. Okay, the other one which will be more suitable will be the color. Okay, there's a paper by David, right? Just now I showed you.
And the item should be in the questionnaire.
Yes, you have to collect as part of your questionnaire.
Can we put those items like not sequentially after 5 or 6 interval?
Yeah, can. You can, as long as you collect them. Okay. Most students who attend my workshop after collecting data, they start to blink because they have not collected the marker variable. Okay, and then they start to worry. I will show you another method called full calling. This is the paper which uses marker variable, the color green.
By David.
So that color green should not be influencing most of the variable we study, right, Abid?
Yeah.
Because you like color green, right? That's why you are very committed. Does it make sense? It doesn't, right?
Yeah.
Okay, so this is a possible marker variable that you can look at now. Okay. So those are some options you have for marker variables.
Yeah, I think with Imran you used in a social desirability. One marker variable.
Most of my PhD students now use the marker variable, which is this cognitive rigidity. Cognitive rigidity. Yeah. Okay. So, yeah. Any other questions on the marker variable? Okay. So if there's no question, you can we can start a new project called. Let me see. Okay, we will start a new project. So we can close this. Oman 2. So we can save this file, new project, create a new project, which is Oman 2. And the new project, the data file is called usage, right? Yeah, usage. These are the files. So I will keep this here. You can start drawing, drag and drop on here. So what will happen is when we go to the model here, okay, here, Oman 2, right? So you can double click. This is the file we want to attach, usage. Then you say, okay. They will give you a descriptive. Double click the Oman 2. So what will happen is you will get this. So I will pull this up a bit. Okay, this is the project that we are looking at. Okay, so now we are doing Oman 2. The data file is usage. Okay, is everybody ready?
176 data.
Yeah, 176 data. Okay, so the drawing of the variable is quite easy. So what you do is you click the first item, attitude 1, click the shift button, click the last item, attitude 5, just drag and drop. Then we click SN1 up to SN5. Okay. PBC 1 to 4. I will put it here. COVID 1 to 4. To the right. Okay. And I will pick usage. Put it to the right. Okay. So those are the variable we want to use in the model. And you can just connect them. 1, 2, 3, and 4. That's it. Okay. Select. And we can change this to black and white now, so you can see it much more clear. Okay. After we have drawn, we have to change the label. So press F2, attitude. And I will click save. Click. Save. Okay, is everybody ready?
Yes, bro.
Yes.
Yes,
Okay.
bro.
Okay, so once the model is ready, the first thing we will do is we will save this file, and then we will run algorithm. Run the algorithm. Okay, So this is the result that you get when you run the algorithm. The first stage of the analysis will be assessing the loadings. The loadings we already decided to cut off at 0.5, okay, 0.5. Any loading less than 0.5, we will delete them. Since they are reflective measurement, we can delete them, okay? So we will look at the first variable called attitude. We have this item called attitude 5, right? Which is very low. Attitude 5, which is very low, 0.243. So we will click on the box and just press delete. No? Okay, we are now deleting attitude number 5 because the loadings are lower than 0.5. Okay, that's the first stage of the cleaning. Yeah.
To ask if that, sorry for the interruption.
Yeah.
While we use Amos, I used to do, like to run the model, then check the output, then based on the output, I usually delete each item and then rerun the model again.
Same.
But here we look at the loading, then we delete all of them at the same time?
One at a time.
Okay. Then we rerun it again?
Yeah, same.
Yeah.
The procedure is still the same. The procedure is still the same. But here they give you the numbers directly. Like in Amos, they don't give you the AV and the CR automatically.
Yes,
but
exactly.
In this software, they will give you automatically. Okay. So the first stage is we are cleaning all the loadings which are less than 0.5 so that that will improve the AVE and the CR. Okay, why we are deleting the item is they are reflective. So we don't have to look at the item. The argument is reflective items are interchangeable. Okay, interchangeable. That's why we are deleting this item, attitude 5. What we will do is we will rerun. And once we rerun, you see all the 4 remaining items are all very high. So we don't have to delete any more items. So this is done. Okay, first one. Then we can move to the next one, okay, which is SN4. SN4 is very low, right? So we will delete SN4 and then rerun. So the subjective norm, all the items are okay. No, sorry, it should be, maybe I deleted the wrong one. Should be item 3, right? Let me see. Okay, we have 2 items here, right? SN4 and SN3, which is low. But we will begin with SN4 first. Delete SN4, run again. If the SN3 doesn't improve, then we will delete also. Okay, SN3 is very low, right? So we will delete. So we have deleted 2 items under subjective norms.
Because in some cases, even just deleting one item might
the
increase
item
the other loading as well.
Yeah. So then you don't have to delete anymore. Okay. That's why we are deleting one at a time. Okay. Now all the loadings are okay, right? Yeah. All the loadings look okay, right? So I move with this so that we can see it much more. Yeah. Okay. Now all the loadings look okay. So that's the first stage, cleaning all loading less than 0.5. Okay. The next step is to check the AVE. AVE. So how do you get the AVE? We have 2 ways. One is looking at the report. The other one is directly from the drawing. To look at directly at the drawing, there's a tab here called construct. Okay, constructs. And now it's showing R square, right? You can click this down and change it to AVE. So what will happen is now inside the circle, they give you the AVEs. The criteria is it must be more than 0.5. So all the numbers are actually more than 0.5, right? This is higher than 0.5. 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 And this is also higher than 0.5. So that's the first step of the second one. After loadings, we are checking AVE. The third one is we click this down, look at composite reliability. Okay, they also give you Cronbach's alpha. They also give you rho A. Okay, but we will only look at composite reliability. Okay, all the composite reliabilities are higher than 0.7. Okay, higher than 0.7. So we don't have to delete any more items. Okay, any question?
No.
Follow up by AVE and then composite reliability. All three done. Huh? Okay, then only we are saying now the measurement model works. Okay, the other thing many people get confused is they think that when the measurement model is good, the structural model will also be automatically good. It doesn't. Huh? A measurement model is looking at measurement only, huh? Whereas structural model is looking at relationship. Okay, that's a different thing altogether. Your measurement model sometimes can be very good, but the structural model doesn't work very well. Huh? Okay, those are some of the things. Huh? So we will put back this arrow to R square so that you don't get confused. So that's the R square you got. Okay, yeah. Okay, so we have done with finalizing the measurement model. So the other way you can get the values that we look at just now, loading AVE and the CR, you can click this button called report. Can you click the button called report? Okay, what will happen is now the report, the text report, this is similar to your AMOS. Huh? In AMOS, we have a graphical output. We also have a text output. Okay, this is actually the text output in Smart PLS. Huh? But in Smart PLS, what they do is they give you the hyperlinks. So in AMOS, you have to scroll down, look at the tab, right? Click the tab, then they will show you your results. Huh? Similar to here, we can also click anywhere we want, and they will show you a result. So here, the first output they're showing is the path coefficient. The path coefficient. So the path coefficient is what we call as the beta values. Okay, the beta values. And if you want to look at the R square, you click the R square. They will give you R square and also adjusted R square. Okay, both numbers are given. Just now we were looking at reliability and validity. You can click this button, construct reliability and validity. Can you click that? Okay, construct reliability and validity. Okay, here they will give you Cronbach alpha. Let me show you. Cronbach alpha, rho A, composite reliability, and average variance extracted. So all the four values are given here. And they have also given you with the color codes. Green, right? Green means you pass, so you don't have to worry. Okay, green means pass, red means fail. Okay, red means fail. Huh? So just now we already assessed composite reliability was greater than 0.7. AVE is greater than 0.5. Okay, which these two values are not given automatically in AMOS. Okay, in AMOS you have to do manual calculation for composite reliability and average variance extracted, correct? Yes.
Yes.
Prof, rho A is for what? We should report this one as well.
Okay, if we are doing consistent PLS, huh?
As consistent PLS.
Okay, this rho A, this is the difference, huh? Okay, this Cronbach alpha and composite reliability, in between is your rho A, huh? Okay, Cronbach alpha always underestimates your reliability. So if your true reliability is 0.8, Cronbach alpha will show you 0.7. Okay, whereas composite reliability, they always overestimate your reliability. So if your true reliability is 0.8, they will show you 0.9. Okay, so because of this underestimation and overestimation, when you do consistent PLS, you have to correct this. So that's where rho A will correct this upper and the lower limit. So this is considered the lower limit. This is considered the upper limit. And this is the true reliability. Okay, true reliability. So those are the three reliability available now in the literature. But for those who are doing structural equation modeling, most people report composite reliability and AAVE. Okay, I've stopped reporting Cronbach alpha for a long time. Abid, in your department, are they still reporting Cronbach alpha?
No, Prof.
In some institutions, they're still doing that because some of the professors will get upset if you don't report Cronbach alpha, because they were trained with that. but most people are no longer looking at this. Huh? Okay, so we will report this and this only. Yeah, any question?
No, thanks.
Okay.
No, Prof. Thank you.
Okay, Nastaran, you were talking about model fit, right?
Yes, Prof.
Okay. In PLS, they give you this too. So I will explain this, but I actually don't like to do this model fit. But sometimes your reviewers force you to do that, right? Okay. You have no choice, Nastaran. Okay.
Yes, Prof.
Here we have three things we can look at, Nastaran. For fit values, in Smart PLS, we have SRMR and norm fit index, which is NFI, norm fit index. Okay, SRMR must be less than equals to 0.08, less than equals to 0.08. Okay, here we have a saturated model and an estimated model. What's the difference is saturated model is your measurement model. Estimated model is your structural model. Okay, so this is measurement model fit. This is structural model fit. Okay, so the measurement model fit for SRMR is okay for measurement. It is also okay for structural. But the NFI is less than 0.9, right? Okay, it should be great. It should be greater than 0.9. Since it's less than 0.9, this doesn't fit very well. This doesn't fit very well. The problem with Smart PLS is there's no option to modify. Whereas in AMOS, if you click the button modification indices, the software will tell you how to modify the model to get better fit. Okay, here we don't have that. Okay, we don't have that. No? Okay, the other thing we can look at is this called RMS data. Okay, RMS data should be about 0.12 to 0.17. Okay, this is slightly higher than 0.17. Okay, so in total, the model doesn't fit very well if you use the fit criteria. If you use the fit criteria. Yeah. Any question, Nastara? Anybody else?
No, Prof. Thank you.
So those are, I also was forced to report SRMR in one of my paper, International Journal of Human-Computer Interaction. The reviewer said, if you don't report SRMR, I will not accept the paper. So I wrote one more line. The SRMR was 0.06, less than 0.08. That's it. These are some of the debates still going on. Fit values are not well established for partially square yet, because we are doing composite. Okay, composite.
Yeah, Prof, I reported only SRMR, so
Yeah.
they accepted. Luckily, it was less than 0.08.
Okay. Most of the time, it doesn't work well. This also doesn't work well, because the model is quite simple, right? So it looks okay. Okay, so yeah.
Thank you.
Okay, so that's how you finalize your measurement model. Yeah, any questions on this?
Here one thing, your saturated model, estimated model, both are exactly same value. Is it right?
Yeah,
or that-
because you don't have like in the problem with this software is this you are using AMOS, right? In AMOS, the measurement model is different from structural model because in measurement model, you correlate all the variables without direct arrows. Okay, here we have direct arrows. Here the measurement model and the structural model is exactly the same. That's why the values are the same. Okay, for those who are in AMOS, you get different results. Okay, this is one of the limitation in this software because we cannot test them without two variables connected. Okay, two variables connected. Yeah, yeah. You had the question, right? Who was that? Who asked the question? Abid? Yeah, Abid.
Yes, Prof.
Somebody asked the question, right? Who was that? Shafiq.
I think
Okay,
Dr.
Shafiq,
Shafiq,
yes.
Dr. Shafiq, I think.
Yes, yes.
Okay, so that's
Okay, that's okay.
That's why the numbers are the same. Okay, here we have
Okay, okay,
the
thank you.
independent together. We run them together. Okay, yeah. So the other thing you can also do is we have a lot of output here, but they also give you indirect effects now directly. But this cannot be interpreted because you don't have mediation at the moment. Okay. And the new thing they added is this called model selection criteria. So if you have different models, you want to see which model works better, then you can use this model selection criteria. They have IKK information criteria. They have corrected and Bayesian information criteria. They have Hans corrected, and these are criteria to assess whether the measurement model is better. Okay, we can compare AIC or CIC or BIC. CAIC, there are many criteria we can use. Okay, for this. Yeah. Okay. Yeah. Any other questions from anybody else before? I think we will stop here for today. Tomorrow morning, we will start with the assessment of step number 1, number 2, number 3, and number 4. Is that okay?
Yeah, it should be okay.
Yeah, because it's already close to 9 already. I think it's already close to 9, no? Yours is close to 5 o'clock, right? Okay.
Yes.
Okay.
No problem.
Yeah, so we will stop here. Tomorrow morning, we will start with the normality testing using the website, and then we will move to common method bias and so on. So tomorrow, I will show you how to report a full model for Smart PLS from sample size estimation until PLS predict, okay, for the model. And then when we move to second order moderator mediator, I will not show you how to report, but I will show you some papers that you can look at. Okay, that's a plan for tomorrow. Okay.
So we need to also install the GPower software as well.
Yeah, GPower should. This tomorrow I will show you. We will start with the calculation of sample size, so that we say sample size is enough, and so on.
Professor, we will focus on mediation and moderation, isn't it?
Yeah, tomorrow. Second order. After we finish the direct model, we will move to second order and then moderation mediation.
Inshallah, inshallah. Thank you so much. Thank you so much.
So we will stop here. Thank you very much. So I will see you tomorrow morning at 9.
Thank you, Prof. Ramaya. Thank you. It's been a fruitful day.
Thank you. Thank you.
Thank you.
Thank you.
Thank you.